So good evening once again, guys. Today we're going to continue our discussion on multiple linear regression. I sent this file on multiple linear regression. So just by way of quick review, we said that in a regression model, we seek to either explain a variable of interest, your dependent variable, making use of more than one explanatory variables or independent variables. Now, two main objectives: to explain or describe your dependent variable using your predictor variables. And the second one is for prediction. You would want to predict your dependent variable using your independent variables. Okay, so that's very important, guys, because later on, when we do the diagnosis, we will find out that if, for example, your residuals are let's say heteroscedastic, no? That hindi siya masyadong magiging problematic, guys, in terms of prediction. Okay, I'll explain that in a while when we go to diagnostics, but it's important for us to identify or to expound on what really is our objective in doing the model. Is it more for explanation or is it for prediction, or it can be both, no? It can be both. Okay, so last time what we did was to explain what our model looks like. Okay, so we have here our variable of interest, our dependent variable, explained by several independent variables plus a certain error term. Why do we have an error term? Because usually there will be a difference between our predicted model, prediction, this one, from beta null up to beta n. That's what we call our fitted value, and the actual value. So there will be a difference between the two, and in order to make your actual value equal to your predicted value, okay, we add the difference between them, which is your residual. Okay, so, and we said that there are several assumptions in regards to using OLS, ordinary least squares, for multiple regression. Okay, I will not go back to the assumptions. Let me just enumerate them one by one. Linearity of the data. There has to be a linear relationship between your dependent variable and your independent variable. We want this to be a very strong linear relationship, but not the independent variables among themselves. Also, the linearity of the parameters means that the model can be written as the beta, the parameter, should not be it should not be squared, it should not be log, it should not be raised to a certain power. Okay, it should only be linear, beta null, beta 1, beta 2, etc. But we said that the independent variables, they can follow a nonlinear form. It can be squared, can be cubed, etc. So no problem with that. Okay, just like this, no? Ito, okay ito. Kasi x sub I1 squared, no problem with that. Square root of x sub 1, no problem. Okay, then the residual should be homogeneous, constant variance. Kasi pag non-constant yung variance, ibig sabihin nun, our model is not able to capture, no, the behavior of your dependent variable. Meron dun sa error term, meron dun sa residual, ang hindi nakakapture ng model natin. Okay? Yung residual kasi natin, dapat yan stochastic, dapat random yan. So if it's not random, therefore yung model natin, which consists of two parts, no? Yung deterministic portion and the stochastic portion. Yung deterministic portion, ito. Yung stochastic, ito. So pag yung error terms natin, hindi siya stochastic, hindi siya random, ibig sabihin nun, there's something here which is not captured in your deterministic portion. Meron ditong movement or behavior dito sa residuals natin na hindi pa natin nasali dun sa deterministic portion of our model, which is the ito yung equation ito. Okay, so homogeneity of the residual variance, and then the explanatory variables should not be multi-collinear. So, dapat walang collinearity sa kanila. Okay. Also, the residuals should not be interdependent. Okay, ibig sabihin kung this is especially true pag may ordered yung natin, yung data natin. If we plot the residuals and then the time, for example, dapat wala tayong makikitang pattern. Kunyari pataas, going up, or up, down, may pattern yun, no? So pag ganun, may pattern siya. Ibig sabihin nun, guys, hindi constant yung variance natin, at saka yung errors natin are dependent. And then last, guys, yung normality of the residuals. Okay, kasi may mga assumptions, guys, yung di ba yung assumptions natin sa OLS, dapat kung hindi ma-violate natin yung residuals, guys, then hindi na magiging possible, hindi na maging best linear unbiased estimator siya. If you recall, guys, yung blue natin, best linear unbiased estimator. This is what happens. This is the parameter estimates that we generate if it follows the assumptions of OLS. Okay. May I know, guys? Sorry, baka na-confuse ako. Did we discuss yung blue, yung best linear unbiased estimator before? Chat naman, please, if we did that. Okay, na-mention. Okay, thank you, Chair. So, just quick, guys, no? Best linear unbiased estimator. So this is what we generate when the assumptions of OLS are followed, no? What's the term for that? The assumptions of OLS are satisfied. Okay? Pag na-satisfy yung assumptions natin ng best linear unbiased estimator, then okay tayo. Sorry, ano ba yung sinabi ko? When the assumptions of OLS, ordinary least squares, which are the 6 that we mentioned above, are satisfied, then we generate the best linear unbiased estimator. Now, yung normality of residuals, actually optional yan. Hindi naman siya kailangan for the estimates of the parameters to be blue. But we'll go to the discussion of that later when we go to diagnostics. Okay, so last time what we did was to, di ba, dinownload natin si wage, no? Okay, we loaded these packages, si psych. These are used for descriptive statistics, si psych, si PaceText, si Stargazer para sa isang good journal ready na presentation ng natin ng, let's say, regression output. Pwede natin gamitin si Stargazer o pwede natin gamitin si JTools. Okay, so we can use those two packages. Mamaya na rin JTools, I think linode natin sa baba. All right, so let's see, guys. Pause muna ako. Are you able to follow, guys? Na-load nyo na ba si wage data? So this is just a quick review of what we discussed last time. Kasi 2 weeks time hindi nag-meet. So medyo okay lang naman na medyo quick review lang. Guys, have you loaded the wage data set? Kindly chat, please. Thank you. Thank you. Right. So, if we look at our wage data set, diba sabi natin, we have 8 variables here, of which ang dependent variable natin dito yung hourly wage. This is actual data, no? Hindi ko lang nalagay yung metadata nito. This is actual data. US data to in the 1970s, I think, if I'm not mistaken. But there were 526 observations, 526 yung sinample nila, yung sinurvey. And then you have here the hourly wage. This is the variable of interest natin. Ito yung gusto natin malaman. We'd like to predict or explain hourly wage based on 7, 1, 2, 3, 4, 5, 6, 7 explanatory variables. Now, of these seven variables, 3 are categorical, and then 4 are numerical. Okay, yung categorical, guys, it's very important to determine whether it can be used as a classifier. Okay, so pag classifier yan, i-convert natin yan as a factor. Okay, so natin itong kunin yung mga descriptive statistics na to. Okay, all right, then we said last time, then when we plot the data, R will not be able to understand what education is and hourly wage. Kasi wala naman yan sa mga objects natin. Ang object natin yung wage lang. So if we want to plot this, we have to identify that the education edu variable is coming from wage. We have to attach this. Or we said last time that we can use the attach function. Pag in-attach natin to, in-attach natin yung wage, then any variable accordingly after that attachment will be understood as coming from the wage data set. So mababasa yan kahit walang wage na linagay natin dito, no? Okay, so let's not do that anymore. Okay, I just plot this last part. Okay, in-extend natin yung x-axis natin. Let's run this. So we can see here a scatter plot of the education on the x-axis, which is your independent variable, and then hourly wage on the y-axis, which is our dependent variable. And most probably, guys, pag magdadagdag tayo ng ano dito, ng regression line, most probably it will be here, which we're going to do in a while. I think ginawa din natin yon last time. Okay. All right, so very quickly, guys, magsisimple regression tayo. Gagamitin natin sa education as a predictor for hourly wage. And I said, guys, last time that it's important to convert your categorical variable into a factor if it can be used as a classifier. So si race, si gender, si civil status, pwede natin magamit yan as a classifier. Okay, so let's run this. Let's now convert yung mga variables na to. Okay. Done na siya. And then let's get the structure of the structure of our wage data set. Okay, and we can now see that they are now factors. Education, experience, tenure, race, gender, and civil status are now factors with 2 levels, non-white and white. Si gender naman 2 levels, then female at saka male. Then civil status, si married at saka si single. Okay, now something happens when we're going to use this as regressors. Mamaya titignan natin. Guys, sorry, parang nalito ako dun sa, when I checked our video, did we get to use yung mga factors na to as regressors or hindi tayo umabot doon? Paki-chat nga please or just unmute yourself. Nakapag multiple linear regression na ba tayo o hanggang simple regression lang tayo last time? Two weeks na kasi yun, no? So, anyone, guys? Pwede unmute ka lang, ha? Not yet. Okay. So, sige. Thank you, Samia. Okay. So this will become relevant later on pag gagamitin na natin predictors yung categorical variables na. Okay. So ang first model natin, guys, kasi ang ginamit natin mod 1, di ba? Mod 1. So we're creating a model here called mod 1. Mod 1. Of course, you can name it however you choose to. And then we're going to use this LM function. Okay, a very powerful function. This is used for linear modeling, where the dependent variable is hourly wage regressed on education, and data is equal to our wage data. Okay, so we have here our predictor. Isa lang muna. So this is a simple linear regression. And then, pag rinan natin to, guys, pag ito lang, okay, pag nilagyan natin ng parenthesis dito, okay, it will, if I run that line, it will generate an output na i-identify lang niya yung formula na ginamit natin at saka yung coefficients. Okay, but there's more than that, a lot more than that. We can get the other outputs using the summary function. Summary natin. Okay, and then we can see here, guys, okay, just ito yung output ng summary natin ng mod 1. First, you have the formula used. This is LM. No? Ang formula, your dependent variables, hourly wage, regress on education. Using the data is equal to wage. And then this is the 5-number summary of your residuals. Ang minimum natin, negative 5.3. Ang maximum residual natin, 16.6. We're going to use that later pag nag-diagnostics na tayo. And then, coefficients natin, okay, you can see here that the intercept, your B null is negative 9.9, and then it's not significant. Education natin, 0.54, and it's significant. So this is the individual t-test of your parameters. And we see that education is the one that's significant. However, we said that even if the intercept is not significant, the practice is it's still used as part of your model. So our model is Y, hourly wage, hourly wage is equal to, our beta null is negative, this one, control C, control V, and then plus this one, control C, control V, and then multiply this by education. There. So that's our model. Then of course, you plus error plus E sub I. Okay, that's our model. All right. So we were able to, we would be able to predict hourly wage based on this model. So if we know education, re-replace lang natin education dito, then makukuha natin yung predicted value ng hourly wage. Okay? So other important things here dun sa model natin is this one. Okay? Residual standard error. 3.378 on 524 degrees of freedom. Okay, multiple R squared tells us how many percent of the variability of your dependent variable, which is hourly wage, can be explained by our model. In this case, our model is, our predictor is education. So education as a predictor is able to explain 16.4% of the variation of the dependent variable hourly wage. Okay, there's a difference between multiple R squared and adjusted R squared. See, adjusted R squared, it's more relevant when when we have multiple linear regression. Okay, later on yung mod 2 natin, we will see the difference between the adjusted R squared and the multiple R squared. Okay, adjusted R squared, guys, it's used particularly when we do multiple linear regression. Okay? Kasi ang nangyayari guys, pag magdagdag ng explanatory variable, na independent variable, tataas yung R squared natin, yung multiple R squared natin. So you can add, kunyari, 100 independent variables. So if you do that, talagang tataas yung ano natin, yung multiple R squared. Pero guys, ang question, relevant ba yung ginagamit natin na independent variable to predict our dependent variable? So in order to penalize the use of so many unnecessary independent variables, meron tayong tinatawag na adjusted R squared. So we penalize guys, pinipenalize natin yung paggamit ng mas maraming independent variables. Kasi ang principle guys, the principle of parsimony, it would be better if you only have, let's say, 5 independent variables which can explain your dependent variable vis-a-vis a model that's 50 independent variables, tapos halos pareho lang yung percentage ng variance na na-explain nila. Okay. In the first place, if you're going to do a research, no? Tapos 50 variables yung sinesurvey mo, naku, that would be time consuming, diba? And also that can be prone to more errors kasi 50 yung minimeasure mo namin variables as compared to just 5, diba? So of course, it's very easily understood na mas maganda kung lilima lang yung ano natin, yung explanatory variables versus 50, tapos pareho lang yung power nila na explain yung dependent variable natin. Okay? Then also we have this F stat. Okay, alam natin na ito, this is the result of what we call the overall goodness of fit test. So itong regression output natin guys, ito yung individual t-test. Okay? Since this is a statistical test, may ano to, there is a hypothesis. No? Ang hypothesis nito, kaya ang tawag sa kanya individual t-test. So ang hypothesis nito is what? Anyone guys? What are the hypotheses for this individual t-test? Anyone? I hope I'm not talking too fast. No? You notice guys that there are many things that I'm assuming here that you already know or you have been exposed to. So dapat as master students, medyo ano na tayo doon, ano? Medyo mabilis na natin sagutin. So ano yung t-test dito guys? Ano yung individual test dito? For example, for the intercept, ang test natin dyan, anyone? Okay, so data null is equal to 0. Yan ang tinitest natin dito. So that's our null hypothesis, diba? And we see that the p-value is 0.187. So ang inference natin dito, we fail to reject the null hypothesis. Okay, there's strong reason to believe that indeed the intercept is equal to 0. But sabi natin, pag intercept, the practice is kahit na statistically equal to 0 siya, we still include that in our model. Tapos dito naman, yung isa, ano yung null hypothesis natin dito sa education? B1 is equal to 0. Okay, so these are null hypothesis. B1 is equal to 0. Of course, yung alternative natin will be B1 is not equal to 0. And so our inference is that, okay, we reject this hypothesis. There's strong statistical reason to believe that B1, which is the intercept or the slope for education, is a value other than 0. It's not equal to 0. Okay? So that's why pinasok natin tong 0.54 na to dito sa model natin. And what is the interpretation of this, guys? Ano interpretation ng education natin? It means that for every 1 year increase in education, there's a corresponding 0.54 or 54 cents, $0.54 increase in hourly wage, a ceteris paribus. Ano ibig sabihin ng ceteris paribus? All things being equal. Ibig sabihin ng all things being equal, guys, That's especially true pag multiple linear regression tayo. Ibig sabihin, ang i-increase lang natin ang isang unit sa education. But the others, we're not going to increase it. So they will just remain the same. Okay? They will just remain the same. All right. Any questions so far, guys? Any questions so far about this, the hypothesis for your individual t-test? And how about the hypothesis for this overall goodness of fit? Itong f-stop natin. Ang hypothesis natin dyan is a beta null is equal to beta 1 is equal to 0. Okay, so you see the difference. No? Ito individual test, ito overall goodness of fit test. So the p-value is also less than 0.05. So ang inference natin dito, we reject this null hypothesis that B0 is equal to B1 is equal to 0. There is strong statistical reason to believe that at least one of these parameters is not equal to 0. Okay, pause muna ako. I've talked a lot, guys. Any questions so far? Quick review lang to, no? Very quick review ng na-discussan natin ng simple linear regression. Guys? Chat naman kung clear so far. Pa-confirm lang guys kung ano. Kung clear siya. Don't hesitate guys kung may questions. Ha? Thank you, Richard. Okay, thank you, Pius. Ina, thank you. Okay, Samya, thank you. All right. Ina, thank you also. All right, good. Salamat. Please feel free to interrupt me or to raise your hands or to unmute yourself if you have any questions. Okay, now here we can superimpose our scatter plot and our regression line. So dito, I think tinanggal ko dito yung ano, no? Huwag na natin i-attach yung wage. Okay? So dito naman kasi no need to attach yung wage kasi dito nakalagay naman wage education and wage hourly wage, no? Okay, we're labeling the x-axis years of education, yung y-axis natin hourly wage, plot character 19, ito yung mga small points, and then frame is equal to false, wag lalagyan ng frame yung plot natin, and then the main title is scatter plot of education hourly wage. And then ito ang dinagdag natin dito yung AB line. This is a line. Ano yung line na ilalagay? Yung line ng linear model ng hourly wage regress on education. Okay? So i-drawing niya kasama ng plot natin, yung scatter plot ng education and hourly wage. It will also draw the regression line. And then the color is equal to blue. Okay, so let's run this. Okay. So you can see here guys, ito. Yan. Okay, so notice guys na yung mga actual natin ng mga points ang layo, di ba, sa ano? Sa regression line natin. Kasi talagang ganun yung data natin, ano? And if we're going to fit a linear regression line dito, okay, you can see that there are many yung residuals guys is the difference between the actual data point and your linear model. Ito yung linear model natin, and these are the residuals. Okay? So ito guys yung OLS, no? Ordinary least squares. Ito na yung line which will minimize the distance of the residual or the error term squared. Okay? If we measure yung mga distances na yan, measure those distances and then square that and then add everything, then we have what we call the sum of the squares of your error terms. Okay, sum of the squares of your error terms, and yun na guys yung pinakamaliit, no? Had we itong line na to, this is your 0.50, 0.54 ba yan? Yeah, 0.54. Ito yung slope ng line na yan, 0.54. And then the intercept is, if we extend this, di ba, pupunta sa negative yun. No? Kasi zero na to eh. Extend this to the y-axis, then nasa negative siya. Kaya nga negative yung ano natin, yung intercept natin. Okay? And I failed to mention again that the intercept, that's the value of your dependent variable when all your parameters, when all your x values are equal to 0. Okay, so ito guys yung model 1 natin, no? Yung simple linear regression natin. Okay, kaya nga 16% lang yung ano niya, yung R-square niya. Konti lang yung na-predict niya. Konti lang yung na-explain ni education. So saan pa kaya yung 83 or 84%? Well, it means that kulang yung variables natin. So there are other variables that can explain hourly wage and not only education. Okay, so let's just take a quick look at what the model 1 object is. Okay, so si model 1 guys, sabi natin, okay, ito yung mga laman niya, no? Okay, in fact, if we take a look at our global environment, ito si model 1, it's a list. If we click this, yan. Ano laman niya? Yan, coefficients. So model 1 consists of 12 objects. Okay, si coefficients, numerical to, no? Double. If I click this, yan. So intercept, data type niya is double, negative 9.04. And then education, it's also double. Ibig sabihin ng double, guys, ano? Diba? May decimal place, diba? 0.54. Okay. And then residuals. Ito na yung residuals natin. We click this, guys. Okay. It's a measure of your error terms, no? Ilan ba yan? Ilan yung residuals? 526 yan. Kasi 526 observations natin. So I will not show that anymore. Okay. So andito din mga effects. May rank. Fitted values are your predicted values. Papakita natin in a while yan. Okay. So ito yung predicted value natin. Alright. And then there are other objects here. No? Call, terms, yung terms, this is your yung formula natin. No? Hourly wage regressed on education. Okay, ano tong model natin? Si model natin dito, hourly wage and then your education. Okay, so it consists of your dependent variable and your independent variable. Okay, so yun laman guys ng ano natin, ng model 1 natin. Alright. So we can actually subset, no? Yung mga elements na ano natin ng model natin. For example, si residuals, no? These are your error terms. Okay, so we can create an object called res1. Okay, and it's coming from model 1 and then $residuals. So let's run this. Okay, so ang dito sa res1, ano? Okay, so it's a vector of numbers, numerical siya, 1 up to 526. If we view this, yeah, ito. Okay, ito yung residuals natin, negative 1.95, okay, etc. Okay, then we can also do that for your predicted values or fitted values. Yung pangalan guys dun sa ano natin, sa model natin. To get the names ng model 1. Ano ba yung mga pangalan dito? Yan, fitted values. Yung fitted values guys, yun yung ano natin, yung predicted values natin. So here I'm creating an object called pred1. Okay, so it's coming from our model 1 and then $fitted values. If you run this, so mag-generate siya ng pred1. Okay, so it's a vector. Okay, 526 all in all. And then i-view natin siya. Okay, ito yung mga predicted values. Okay, just okay, and then we can actually use the Broom package. So if you have not installed this, guys, paki-install muna sa Broom package. Okay, and then i-require natin siya because we can make use of the augment function of Broom, the Broom package. Pwede natin magamit yung augment function, and then pwede natin mag-generate yung data, information about yung diagnostics, the metrics on the diagnostics of Model 1. Okay, so since na-install ko na si Broom, hindi ko na siya i-install. I-require ko na lang siya. And then I'm going to run yung unang object natin, yung mod1. So where's that? Okay, then I should print ko na lang ito. No? Kahit ano na lang, head na lang. Yung first 6 na lang, head, mod 1, okay. Right, so here are my first 6 elements ng object na to. Model 1, diagnostics.metrics. Ang laman niya, guys, ito, yung dependent variable natin, and then our independent variable natin. And then this is our fitted, ito yung predicted value natin. Residual, ito yung natin, ito yung error terms. Okay, yung that hat, I think this is the standard error of your fitted values. Okay, that sigma is that sigma. If I'm not mistaken, this is the standard deviation yata to, or the standard error. We'll check later, no? I forgot what that sigma is. Pero it has something to do with the standard error or standard deviation. And then the Cook's distance, okay, sinama niya yung Cook's distance dito. Ginagamit to, guys, in order to determine if an object or if an observation is influential. Okay, influential, that's different from an outlier. Okay, an outlier may or may not be an influential observation. However, an influential observation will always be an outlier. Yun ang distinction ng outlier at saka influential points. Influential points, guys, are critical in the sense that removing them will change the values of your regression parameters drastically. Pag tinanggal natin siya, magbabago yung natin, yung drastic, yung malaking pagbabago ng regression parameters natin. So this later on, pag diagnostics natin, titingnan natin ito yung influential points kasi you have to determine, guys, you have to investigate further. Bakit ba siya naging influential? Bakit siya outlier na influential pa siya? Ano yung reason? So mali ba yung pag-record niya? Was there a translation mistake? Ibig sabihin translation, kunyari 98.1 naging 9.81, parang ganun na mali yung decimal place. Because that could change the output tremendously. Okay, so yan, guys, ang natin. And just by way of reminder, guys, ano yung residual? Okay, so I don't think na sinama ko sa inyo to, but dapat lalabas yung dito. Yan, guys, no? Ang residual natin, epsilon sub I, is simply equal to your actual value minus your predicted value. Okay, you may just include that, guys. Alam natin yung $, that will center the value of the formula. This is epsilon underscore I. That's your subscript, no? it's equal to y underscore I, naka-subscript din siya, minus. So pag hat guys, ito, okay, this is backward slash, forward slash pala, then hat, and then brackets y, and then itals pa I. Okay, so that's just how to write this. Kasi guys, yung susunod na project nyo is a regression, multiple regression. So kailangan isusulat nyo rin mga equations, and just by way of reminder, yung latex natin, di ba? Yung inline at saka centered formulas, you have to know how to generate this. Okay, so let's go here. Ito guys, very powerful yung ggplot2 for data visualization. So I think we have installed this in ggplot2. So i-require na lang natin siya, library. Tapos last time we learned how to plot this. So it uses the function ggplot, and then dapat i-identify muna natin data, and then yung mapping or aesthetics. This is used in order to define your coordinates. No? So if pina-plot natin dito, yung sa x-axis natin yung predictor, si education, and then sa y, si hourly wage, and then plus, yung another layer would be our scatter plot, our geom point. Okay, and then plus, naglagay tayo dito ng regression din, guys. Okay, method is equal to ln, SE is equal to, I think ang nakalagay dyan sa inyo false, ano? So, nagyan natin false. Pwede rin naman true. And then, may kasama pang geom segment. Yung geom segment, guys, it identifies yung mag-create ng segment from the end of education up to the end of yung fitted value. So magdodrawing siya ng vertical line kasi diba yung education from X end, which is in education, up to Y end, which is your fitted value. Okay, and then color is equal to red, and then size is equal to 0.3. So let's run this, and then it will generate. Okay, ano nangyari dito? Okay, sandali, ha?
Nasaan yung siguro ko? Ha? Kaya?
Okay. Errors, installing of packages.
Sana sinalat ko?
Nag-run ba sa inyo, guys? Na-install na natin, di ba, yung live, yung ggplot?
Nag-run, sir.
Ha? Nag-run? So nakita niyo yung red color ng ng distance between the predicted value and yung regression line at saka yung actual value.
Yung meron from my end, sir, residuals versus fitted. Tapos quartile, and graph. 4 graphs, sir.
Wala, dapat isang graph lang yan kasi plus lang. Dali hangtong mo. Error yung installed packages. Okay. Alright. So escape ko muna. Install ko tong install ko sa library yung si ggplot2, and then I'll highlight this. Highlight ko to, guys. Control enter. Yeah, okay, we should run. Okay, you should have generated this plot. Okay. Paki-chat please, guys, kung pareho tayo ng plot.
Yung na-mention ko pala earlier, sir, GG45 yun.
GG4, iba yun. Sa ano yun? Sa residuals na yun, no? Pareho ba? Yeah. Thank you, Ina. Ina, pareho, no? Okay. Samya, Payus, kamusta? Andiyan pa ba si Payus? Baka na ano na-log off si Payus. Andiyan pa pala. Okay. How about chart, nakuha mo to?
Nag-error sa akin, sir. Sorry.
Error? Okay, i-run mo muna si ggplot, no? I-separate mo na i-run si ggplot yung library. Na-install na natin yung, di ba, yung package na to last time. And then i-highlight mo tong code chunk na to.
Okay.
And then you run it. And then you should be able to generate this. Nag-run, chart?
Wait lang, sir.
Sige lang, no? Sige, while we're running it, explain ko lang siya, no? Now, ito yung scatter plot natin, no? Scatter plot natin ng hourly wage on the y-axis and education on the x-axis. Yung mga points na to, yung mga plot character 19 na to, these are the plot of hourly wage and education. Okay? Yun yung mga plot nila. Yung mga points na yan. Tapos, this blue line here is your regression line. Ito yung y is equal to negative 0.9 plus 0.54 times your education. So this slope is 0.54. Ibig sabihin nito, for every 1 year increase in education, there's a corresponding $0.54 increase in hourly wage. Okay, but if you take a look at this, guys, kung i-add natin yung mga residuals, kunyari, yung residual na ito, itong point na to, from here up to here, ganun kalaki residual na yan. Okay, and then we square that. So lahat ng mga residual is square natin. We add them all, guys. That will give us the sum of the squares of your error terms. Okay, sum of the squares of your error terms. So medyo malaki yung ano natin, no? Yung sum of the squares of the error terms. Okay, kasi nga yung model natin, no? Medyo yung ano natin, yung data set natin, medyo malaki yung variation ng ano nila, ng value ng hourly wage with respect to education. Okay. So let's go muna to. All right, then okay, now sabi natin, guys, we don't stop there. Okay, a good a linear model, guys, should not stop at us determining kung ano yung what's the model. Okay, by the way, guys, dali mo chat dito. Sabi may ano tong ano? Restart PNG. Prompt sa'yo. Okay, sandali, guys. I'll make you all co-host para ano, so that if you have problems, okay. So Samya, can you share your screen? Stop share lang ako.
Restart it and then install yung ggplot. Pero whenever I try to do so, lagi lang nagpo-prompt yung message na yun. Not sure lang, sir, why. Wait, I'll show my screen, sir.
Lagi nagpa-prompt.
Yes po. When I try to run, sir, yung pinaparun, yung kanina.
Sige, pakita mo nga.
Sure
Can you
lang.
share your screen, please? Let's see
Eto,
what.
sir. Can you
One.
see my screen, sir?
Oo, yeah. Oo.
There. Parang, when I try to run this one, tapos lagi itong magpo-prompt, tapos pag ni-yes ko lang, uulit lang siya ulit.
Uulit lang,
Tapos,
ano?
parang ulit lang siya. So, not sure lang po why.
Yeah, minsan you have to, importante na na mabasa natin yung message kasi minsan,
Ayun, sir.
same
Ulit
error
lang
rate
siya
kay
ulit.
minsan may sinasabi siya, kunyari yung may isang kunyari minsan R lang sinasabi niya, which is a package. So you might need to reinstall that, no? Yung
Okay. We'll
yung package
reinstall
na
na lang.
sinasabi niya. Oo. So
Mm-mm.
kunyari may package na sinabi, what you can do is first remove that package, no? So remove that packages naman instead of install that packages. Remove that packages and then remove yung package na yun and then install mo ulit, no? Install mo ulit.
Sige, sir.
Sige, pero this time,
Well,
sige, tingnan muna natin sa console mo i-run, sandali ayan no, ano mo na.
opo nga eh. Well, I'll try, sir, to remove tapos install. Tapos chat na lang.
Sige, before you do that, let's check muna kung, kasi okay na yung nag-install na yung ano. Ako minsan, ang
Opo.
ginagawa ko, instead of installing it dito sa, ewan ko, minsan, pag ini-install ko siya dito sa, sa script window, no? Nagkakaganyan problema siya. Pero pag dito ko siya ini-install sa console, minsan gumagana siya, no? So minsan pag if I'm experiencing that, ang ginagawa ko, doon ko siya i-install sa console. Okay.
Sige, sir.
Let's see muna kasi sige nga i-library mo nga, sa console natin ilagay, no? Samya, library ggplot2. Sige, tingnan natin Sige, enter mo siya. Oops. Kahit wala nang codes. Enter mo. Control enter. Okay, so na-load na siya, no? Sige, i-highlight mo yung ggp, yung sa line 257 dito sa script window natin. Yan. Yan. And then control enter. Wag yan. Sige, pwede rin pala yan. Or control enter. Kasi pag hinahighlight mo siya,
nawala lang siya, sir.
Tapos pag inun mo ulit yung, minsan kasi pag ang rinan mo yung code chunk na to, yung buo ulit no? Iralan ulit kasama yung yung install at saka yung ggplot, no? Kaya nga pag hinighlight mo lang from row 257 to 260, pag hinighlight mo siya, ang gawin mo, control enter lang para sigurado kung yun lang yung mararan. Sige, paki-ano nga ulit.
Sige.
Control enter. Error in object. Hindi mo pa nararan si no? Go back to, naran mo na si broom. Naran mo na yung broom package natin.
Sige, sir. We'll look for that po.
Sige, let's i-ano natin para makita natin. Sige, baba pa. Sige, baba. Asan natin rin-load yung yung broom. Nasa broom siya. Anong row yun? Sige, up.
Yung import, sir.
Yung install that packages, yung broom. Anong line siya? Iba yung ginagamit mong file, Samya.
Okay, iba kaya. Sige. We'll download na lang, sir. Sige po.
Sige. Okay. Kasi ando dun, medyo binago ko yung yung file na yun, no? So, i-open mo na lang tapos
sige, sir. We'll try to run that.
Sige. Sige. But at least na na natin, no?
Sige po.
Okay. Sige. Ang gawin ko para mas mabilis, sige sandali. Okay. Mag-share ulit ako Ito yung control C. Ilagay ko na lang dito sa chat para so that you can easily yan, no? So ginamit natin nasa chat guys, no? Library room. If you haven't installed that, i-install nyo, no? Tapos nag-create tayo ng model 1 diagnostic metrics na object. Yun ang ginamit natin para i-plot guys yung natin yung residuals, no? Take a look at this. Okay, saan na ako? Okay, here. No? Nag-ggplot tayo. Ang data natin, yung model 1.diagnostic.metrics. Okay, we're not using the wage data. No? Ibang object to. Ito yun. Then if I... Okay, so ito yung object na yun, di ba? Yung dependent variable natin, independent variable, yung fitted, yung predicted value, yung residual, yung that hat, this is the standard error of your fitted values. That sigma standard error ng ano ba to? I'm not sure pero let me check no. Standard error ng residual, di yata. Cook's distance and then standard residual ng ano, standard error ng residual natin ito. Sigma yata, this is your standard deviation. Okay. All right. Now let me just guys let me just i-validate lang natin to, no? Is kahit isang row lang din natin. So, di ba sabi natin, ano ba yung ano, mod 1, dito ko ilalagay, no? Mod 1 dollar mod 1. Ito yung model 1 natin. Let me just access yung dollar coefficients, no? There. When I type model 1 and then dollar, lalabas yung laman niya. Coefficients, residuals, etc. So let me get the coefficients there. So ito yung coefficients natin, di ba? Okay. Now, let's predict, no? Let's predict hourly wage for the first observation, where education is equal to 11. Sige, copy ko to. Control C, Control V. So di ba yung model natin negative 0.90 plus 0.5. Okay, 0.54 times. What's our education? For the first observation, education natin ito 11. So times 11. Okay, so that's the predicted value for the first observation. We should be getting around 5.05. Okay, so let's run this. Yan, diba? 5.0501. Okay, so that's our predicted value. Okay, and then what will be our residual? We're going to compare yung actual value natin, which is 3.1. So, Control C, 3.1. So that's our actual value minus the predicted value. This is our predicted value. Control C, Control V. No, this is our y hat, di ba? This is our actual value y minus your y hat. If we run this, negative 1.95. Yun yung residual natin. Okay? So doon ang galing to guys, no? Doon ang galing mga fitted values, residuals, lahat yan kinompute given your education. You multiply the years of education by 0.54, add negative 0.9, then you get your fitted value. And then the hourly wage minus your fitted value, you get your residuals. Okay? Alright. Pakichat na lang please guys kung okay tayo so far. Clear ba tayo? So far, dun sa yung sa how the fitted values, how the residuals were computed. It's important for us to know where they're coming from. So first, nag-generate ng linear model. Okay. Tapos ginamit natin linear model natin and substituted whatever the values of the independent variable to get your predicted value or fitted value. And then si fitted value, kinompare natin sa actual value, nakuha natin yung residual. Okay, paki-confirm nga guys kung naintindihan guys yung ano natin, yung mga values na to, yung fitted values, residual values. Appreciate your feedback, please. Hello. Paki-chat naman please kung naintindihan. Thank you. Thank you. Okay, pag may questions guys, ano lang feel free to hindi naman to sprint, no? This is more of a marathon journey natin to. Okay, so we have our model already for our simple linear regression, but it doesn't stop there. We need to do diagnostics. So sa diagnostics, ang pinaka-importante yung residuals. Tinitingnan natin yung behavior ng residuals natin. Number one, di ba, dapat yung residuals natin, dapat constant yung variance yan. Hindi pa pwede yung variance natin may fanning out yung palaki, no? Or funneling out, ibig sabihin paliit. Hindi pwedeng ganun. Kasi pag ganun guys, ibig sabihin, hindi natin makapture yung may mga movements dun sa dependent variable natin na hindi makapture ng predictor natin. Okay, so there are several ways to do this. Okay, so you can use the plot function. A plot function, ito, partition, MF row, two rows, two columns. Ipa-plot 2 rows, 2 columns yung whatever the result of your plotting model 1 is. Remember guys, model 1 is a list, no? Pag ginamit natin yung plot function on a regression model, meron siyang actually 5 plots, no? So ito sa isang plot yung 4. So let's run this. Okay. So this is now your diagnostics, no? You notice guys that yung nasa x-axis nasa y-axis natin, they're either residuals or standardized residuals or square root of standardized residuals. Basta lahat siya residuals. Okay, itong number 1 plot natin, yung residuals natin is plotted against the fitted values. So ito guys, 3 pinapakita sa atin ito. This shows us 3 things. So what are those 3 things that we can learn about this? Yung plot number 1 na to. Okay, number 1 guys, ang pinapakita sa atin ito, yung meron bang linear relationship yung natin. Yung number one assumption, there should be a linear relationship between your data or your variable, dependent variable, and your independent variable. If the plot, kung yung plot natin guys, yung red line na to is close to this horizontal line, okay, then that means that may linear relationship yung natin, yung data natin. In this case, medyo that's questionable, no? Kasi hindi siya, it does not really follow the horizontal line. Okay, yung y is equal to 0 na to. Okay, it does not follow this. So medyo may may trend ng ganito, no? There seems to be a pattern. So that's the number 1 thing that we can see here. Pangalawa guys, ano pa makikita natin dito? Makikita natin dito guys kung constant yung residuals natin. But you can see here guys that there's a funneling, no? A fanning, F-A-N-N-I-N-G. Kasi if you take a look at the different levels of your fitted values, ito yung prediction natin, you notice guys that at certain levels of your fitted values, predicted values, yung variance natin ng residuals, it's not constant. Ayan. At this level ng fitted values, ito yung variance, no? At this level, ito. So, kaya sabi ko kanina may fanning out, no? Lumalaki. Across your fitted values, the variation of your residuals is not constant. So ito guys, non-constant variance ng residuals. Therefore, our model suffers from heteroscedasticity. And number 3, the presence of outliers. Itong 15 and 112, okay, these are outliers. Sabi niyan, si point number 15, observation number 15, and si observation number 112, these are outliers. Kasi malayo siya dun sa horizontal line ito. Naka-identify na. Number 15, observation number 15, Observation number 112. So dito sa number 1 pa lang guys, makikita na natin na may problema yung model natin. And that's partly because simple linear regression lang, no? Okay, simple linear regression lang. Actually, another way to do this plot, if you want just the first plot, mod 1, and then we can use the which. Ano? Plot model 1, yung regression 1 natin, and then which is equal to, so which of the plots daw, which is equal to 1, enter natin, okay, and then it will give us just the first plot. Okay, so ito yung first plot natin. So mas enlarge siya, naka-zoom. So we can see here that there is a problem with the linearity of the data. Yung linear relationship ng natin ng dependent variable at saka independent variable natin. Okay, mas kita natin dito outliers number 15, number 186 and number 112. Okay, these are outliers. Okay, okay lang guys kung may outlier, but we have to check if they are influential data points, and there are statistical ways in order to determine kung ano siya, no? Kung if they are influential data points. Okay? Alright, any questions guys? Kung generate natin to, ginamit lang natin yung which is equal to 1. Okay, of course, this one, yung plot number 2, ito, no? So let me run this here also. Control C and Control V, which is equal to 2. Okay. We generate this normal QQ plot, the quantile plot. Zoom natin. Okay, what does this tell us, guys? Ganun din. Diba, one of the assumptions of the classical linear regression model is that our error terms should be normally distributed. Although yung normality na residuals, as I said before, it's not a prerequisite for the best linear unbiased estimator. Pwede yung residuals natin non-normal, pero still blue pa rin yung model natin. Okay, so we can see here that ito yung quantile plot natin. This is 45 degrees. Okay, 45 degrees to guys. And you can see here, yan, na far from normally distributed yung residuals natin. Okay, kasi dapat yung residuals natin very close to this quantile plot. Itong dotted line na to. But you can see here that towards the yung mga higher values natin, medyo malayo dun sa QQ plot natin. And here, naka-identify din 112, 186, 15. Troublesome na mga observations to. Okay. Alright. Number 3 naman guys, ito yung plot number 3 natin. This tells us standardized residuals at saka fitted values. This also tells us kung homoscedastic yung distribution ng error terms natin. Control C, Control V, which is equal to 3. Yan. Okay, so pareho lang siya dito. Right. Dito na naman si mga outliers, and dapat guys, straight line lang to, no? Straight line lang siya. Yung red line na to. To indicate that tsaka guys yung distribution ng residuals natin, may fanning out, going here, di ba? Hindi constant yung variance natin. Dapat yung variance natin, it should congregate in a certain band, no? Dapat doon lang siya naglalaro, tas random siya, dapat walang pattern. Ito kita natin na may fanning out. So this just reinforces the fact that our residuals are heteroscedastic. And last guys, ito yung leverage. No? However, dito sa leverage guys, which is equal to 5. Which is equal to 5. Skip ko muna yung 4. No? Kasi ito yun. No? Yan. Ito yung Fuchs distance. Pareho lang dito. So, how do we read this? How do we read this guys? Okay. kung may mga data points na outside the dotted red line, ito yun. Ito yung Cook's distance, guys. Ito. Ito yung 0.5, no? Okay, so itong 1112 mukhang doon siya sa border yung 0.5. Yan. 359 hindi. 379 hindi. Okay, yung Cook's distance, guys, determines or tells us of possible influential data points. Ano yung gamit ng influential data points? Influential data points are important because we said that determining influential points require us that investigate that particular data point. Kasi this data point, if you remove it, no, if you remove it, it can really change the regression output. So i-investigate to. Ano saan ba nanggal? Ano ba yung ano? May mali ba to, guys? Nagkamali ba to? Okay, you don't automatically remove this, no? That's the last thing that should be done. In fact, yung iba, kahit na may influential data point dyan, they still maintain pa rin nila yan. Okay, so we'll discuss this in greater detail when we formalize our discussion on residuals. Ito parang introduction lang to, guys, no? Alright, and there's another one, yung 4. This is also yung 4, guys. Hindi siya pinapakita dito, no? It tells us also Cook's distance, number 4. Okay, plot natin. Okay, so notice, guys, wala siya dito, di ba? This is, you can only generate this using this. Okay. So ito, ganun din, guys, Cook's distance. Okay, si 1112, siya medyo mukhang strongest candidate. Si 1112, si 0.59, saka si observation 379. Of course, guys, hindi lang natin titingnan yung plot. There are statistical methods in order to determine whether these indeed are influential points or not. Okay? So we learned how to generate this, yung plot na function ng base R. Ipa-plot natin yung model ng regression natin. Mag-generate siya ng actually 5, no? 5 plots. Dito sa automatic plot natin, 4 lang siya. Hindi sinasama yung ano, no? Hindi sinasama yung 4. Kahit na gawin pa natin tong ano, no? Gawin natin let me see. If I make this 3 rows and 2 columns, let's see, huh? Okay. Here. Okay. Hindi rin niya sinama, guys, no? Hindi niya sinama yung Cook's distance. It doesn't, kahit na ginawa ko pang 3 rows and 2 columns. So you can only generate that by using yung which, no? Which is equal to 4. Okay? All right. Questions, guys? Questions about this? Clear ba?
Question, sir.
Yes, start.
Sir, kunwari, based dun sa 5 graphs kasi kanina, we see na merong heteroscedasticity yung data.
Yeah.
Yung, confirm ko lang, sir, yung pagko-correct nun is pwede kong i-remove yung outliers and pwede ko ding i-transform?
Yeah. Yung removal, that's the last thing that you should do.
Hindi pwedeng choice number 1 yun, sir. So, hindi pwedeng i-remove? Kailan, parang
Okay.
may method, sir?
First, investigate mo. Bakit kaya naging ganun? Bakit kaya siya outlier or influential point? Kasi possible na may error. Error dun sa pag-input. Kunyari, dapat 98.1, naging 9.8. So that's a translation error, di ba? Or there can be different ways na nagkamali dun sa pag-load ng data. So yun ang muna titingnan. Now, secondly, nasa ano na to, based na sa area of study nyo, no? Kung talagang medyo outlier siya, kung talagang sabihin natin na, kunyari, we're studying yung hourly wage ng mga ordinary employees. tapos by chance napasok niyo kunyari yung ano ni Bill Gates o ni Elon Musk. Kunyari lang, I might be doing a very hyperbolic hyperbolic example. Nasama yung data ni Elon Musk, the richest man in the world. Nasama dun sa mga ordinary na na data ng mga empleyado. But definitely talagang magiging influential. Ang layo-layo na, di ba? So, medyo hyperbolic siya na sabi ko, but that's the case when dapat siguro tanggalin yon. Kasi hindi naman talaga dapat siguro kasama siya sa sample natin. Kasi masyadong malayo na siya, hindi naman talaga yun natin, hindi talaga yun yung objective ng study natin. However, there may be instances when talagang kasama siya. Talagang kasama siya. So in that case, there may be remedies about that. So you may choose to just leave it as is and then i-explain mo na lang sa result mo na merong outlier na ganito. And later on titingnan natin na kahit na outlier yan or influential point yan, pag maintain natin yan, should I say this now? Sige, mamaya, saka na lang guys, pag talagang kinuha na natin statistical test. No? Kasi hindi lang pwedeng ganyan lang eh. No? Titinalan natin visually. Although it helps. Kasi merong mga test. No? Kunyari, sa influential points, pwede natin gamitin yung D-fits na DF fits at saka DF beta na functions para malaman natin talaga kung influential point. And back to your question, kung influential siya, yun ang tanong. Anong gagawin natin dun sa influential point na yun? Okay. Ang mga remedy, tingnan kung nagkamali. Pangalawa, kung tama man, anong pwede natin gawin? Either maintain mo lang yan or remove it. Okay. So yung pag-remove or yung pag-maintain, that has to be a decision to be made by the one doing the research.
Thank you, sir.
Sir, na-answer ba yung question mo?
Yes, sir. Yung transformation,
Yeah.
sorry, hindi pala transformation. Hindi ko alam kung para yung term, sir, na transformation tsaka ino-normalize yung data.
Yeah, we will do that, no? We will do that.
So, sir, dun sa related question ko, sir, ibig sabihin, before I consider removing yung outlier, okay lang i-try muna.
Yeah, of course. Of course. Pwede natin i-center, pwede natin i-normalize. In other words, i-remedy muna natin kasi minsan yung heteroscedastic na na residuals, nare-remedy yan guys ng centering the data. Pag sinabi natin center, di ba? It's the value of your variable minus the average. Okay, yun ang centering. Yung normalizing naman, it's the value of your variable minus the mean divided by the standard deviation. Okay, para ino-normalize mo siya. We will have an example of that. Don't worry, no? But thank you for that question, Chart. That's really a very important question. Sa usually nagkakaano to pag mga sa finance, hindi naman siya masyadong hindi naman siya masyadong problema. Except lang kung may mga anomalies dun sa data natin. Anomalies can be sources of influential data points. Lalo na kung tinitingnan natin, for example, nung global financial crisis, grabe mga anomalies sa mga data niyan. Kung tinaan natin yung mga returns, etc. Kung minomodel natin, okay, I've seen some studies na may mga influential data points kasi nga because of the anomaly that happened during the global financial crisis. Okay, Chart, did that answer your question?
Yes, sir. Thank you.
Okay, sige. Thank you. Thank you for that question. Okay, so kanina, di ba we learned how to plot yung regression model natin? And then sabi natin, ito ginagamit natin to sa diagnostics. And another exam nyo guys on multiple linear regression, I expect you to diagnose your model Hindi pa pwedeng na-generate na yung linear regression model. Tapos na yun, may model na kagad. Hindi pa pwedeng ganun. Kailangan i-diagnose natin. Okay? And another way to plot to plot yung kanina guys is making use of this package GG45. Okay, if we load this and then gagamitin natin yung auto plot ng model 1. Ako I prefer this kasi mas maganda yung yung pag-plot niya. But not so much difference. Ganun pa rin naman. Yan. Okay? Okay, so it's a matter of preference, it's a matter of taste. So you can save this output, guys. Okay, actually hindi nyo na siya kailangan ilagay as image kasi ma-generate naman ang code na yan. Okay, you got me there, guys. Kunyari, may assignment, no? May exam, take-home exam. Tapos pina-generate ko kayo ng multiple linear regression plus the diagnostics. Siyempre, pwede nyo gamitin to. And then, ito na yung plot na yun. You don't have to save this as an image and then i-load nyo dito. Kasi, andyan na naman yun eh. This code already will generate this plot. Okay. So, pareho lang yan guys. Yung 1, 2, yung 4 plots na yan. Just the same. Right? Then here guys, you have some explanation on the 4 plots that we just looked at. Okay, so now guys, we go to multiple linear regression na tayo. Hala, naka 1.5 hours tayo sa review. That's okay. All right, so we won't run this anymore guys. Kasi, in-as factor na natin siya, no? Diba, si race, si gender, si civil status, as factor na siya. Okay, then, alright, so using the site package, pwede tayong mag-pierce that panels ng wage data natin. If you run this, makikita natin yung correlation ng mga variables. Let me just okay. So ito yung function yun from the site package, no? It will give us the relationship between your variables. Remember guys, ang gusto natin that our dependent variables, si hourly wage, should be highly correlated with your independent variables. If you take a look at this, hourly wage, correlation niya with education is 0.41. Si experience, 0.11 lang, so mababa. So, pwede natin hulaan na between education and experience, kung may magiging significant dyan na predictor, it will be education as compared to experience. Kasi si experience, 0.11 lang. Si tenure pwede kasi 0.35. Okay, and then we will not anymore si race, si gender, si civil status. Okay, since they are factors, no need to interpret this kasi factors naman siya. And the number of dependents, it's negatively correlated, negative 0.05. So there's a negative correlation between hourly wage and number of dependents, which means that as number of dependents increases, hourly wage decreases. But the question is this statistically significant? Okay. So, however, guys, when we compare naman yung mga independent variables among themselves, gusto natin na hindi sila highly correlated. So for example, si number of dependents, is it correlated to education? Hindi naman, no? Negative 0.22. With experience, hindi naman. Weak siya, weak correlation. Okay, so how about education, guys? Education with experience, negative yung correlation niya, 8.3. Education with tenure, okay, mababa din, negative pero very low. Okay, so this is what we want, guys. Yung mga correlation ng mga independent variables natin are very low. Otherwise, kung merong highly correlated, kung mataas yung correlation, magkakaproblema tayo sa multi-collinearity, which we're going to discuss later. Ano yung implications ng multicollinearity? Okay, so, all right, let's
Kaya
now
lang yung natitirang ano.
let's now generate a new model 2 na tayo, no? And we would once again use the LM function. Hourly wage regress on, gagamitin natin yung pitong the 7 independent variables, which are education plus experience plus tenure plus race plus gender plus civil status plus number of dependents, and the data is equal to our wage data. Okay, so this is how we write our model in R, or this can be written as model 2. Okay, we're creating this object model 2, and then LM, linear model, hourly wage, our dependent variable, regress on that. Ibig sabihin ng that dito, guys, lahat ng mga independent variables, then i-define natin yung data is equal to wage. All right, so we can either run this or run the first one. It doesn't matter. They're the same. Okay, so let me just run the first one. Ito yung model 2. And then take note, guys, since naka-parenthesis siya, pag rinan natin to, bibigay sa atin kagad yung formula at saka yung coefficients. Okay, yung values ng mga parameters. Alright. Then, we go here. I-summarize natin. Alright. Okay. Now we interpret this. Okay, so anong ibig sabihin nito? Yung output natin, guys, is number 1, anong formula yung ginamit? And then residuals ng descriptive stat ng residuals, minimum residual, negative 7.5, maximum 13.9, median is negative 0.53. Okay, and then we have the individual t-test dito. And then here we have your ANOVA. Unahin muna natin si ANOVA para very quick. Okay. You have here the residual standard error, and then on dalawang degrees of freedom, 7 and 518 degrees of freedom. Okay, ano ibig sabihin ng DF1 natin? DF1 is equal to 7, which means ilan yung regressors natin. Okay, so this is the degree of freedom 1. DF1 is equal to 7 kasi ito yung regressors natin. Education, experience, tenure, race, gender, civil status. And the next one is your 518. Saan ang galing itong degree of freedom 2 na to? Degree of freedom 2 is your n minus k then minus 1. Where your n is your number of observations, your k is the number of predictors, and then adjusted for minus 1 kasi we lose a degree of freedom because we also estimate yung intercept. So degree of freedom 2, ilan ba yung natin, ilan ba yung data natin? 526 minus regressors 7 minus 1. So that gives us degree of freedom 2, 580. Any question? Chart, actually ginamit natin yung binigay ko sa inyo yung S. No? S, itong hindi ko sinare sa inyo April 18 kasi that's for today. So ang question na Richard, iba yata yung file na ginamit ko ng April 18. Yes, I'm using a different file.
Okay, sir.
Pero yung S, that introduction to regression, halos pareho lang yan. May mga konti lang akong dinagdag. Kasi ginamit ko to kanina, no? And then, linagyan ko ng bagong date na April 18.
Okay, sir. Clear, sir. Thank you.
All right. Sige. Thank you for that question. Okay, so 7 degree of freedom 1, degree of freedom 2 is 518. So the p-value is less than 0.05. No? So again, ano yung hypothesis ng overall goodness of t-test. Ang hypothesis natin dyan, beta null is equal to beta 1, is equal to beta 2, is equal to dot dot dot, is equal to beta 7, is equal to 0. Okay? 7 kasi yung regressors natin plus the intercept. So sabi natin, lahat yan equal to 0. And then ano yung conclusion natin? We reject this null hypothesis that all the parameters are equal to 0. There's strong statistical reason to believe that at least one of these is not equal to 0. And true enough, guys, if we take a look at the regression output, the individual tests for the parameters, meron tayo dito mga significant na non-zero. Okay, so let's first analyze this. So if we take a look at our model 2, intercept is significant at 0.1%. Paano ko nalaman na at 0.1%, guys? Pag tatlong stars yan, ito yun, significant at 0.001 or 0.1%. So 3 stars, kung 1 star, guys, that's significant at 10%. Sorry, yung that, hindi 1 star. Ang 1 star kasi significant at 5%. So itong tenure, significant at 0.1%, also your gender name. Okay, now let's take a look at this kasi medyo naiba yata yung output natin. No? Okay, number 1, education. So education is significant. P-value is practically 0. It's less than 0.05. So what does this mean? Interpret na natin to, no? So for every 1 year increase in education, there's a corresponding $0.57 increase in hourly wage, comma, ceteris paribus. So kailangan isasalin natin to, no? Ceteris paribus, which means all things being equal. Ano ibig sabihin nun? Increase natin sa education ng 1 year, the rest wag natin i-increasean. Do not let the others change. Hindi pwede sa education mag-i-increase ng 1, sa experience din mag-i-increase ng 1 year. Hindi pa pwede. Dapat sa education lang ang i-increase natin ng 1 year. So if we increase education by 1 year, there is a corresponding $0.57 or 57 cents increase in hourly wage, ceteris paribus, which means all things being the same. Huwag babaguhin yung iba. Okay? Kasi kung binago natin sa experience ng 1 year, edi may marginal effect din to, yung 0.02. Diba? Alright? So yun ang ibig sabihin ng 0.57 na to. Okay, how about experience? Assuming that we're using a level of significance equal to 10%, so papasok to, no, sa experience kasi 0.07 yung p-value niya. So what does experience mean? So for every 1 year increase in experience, there's a corresponding 2 centavos, kasi 0.02, per hour increase in hourly wage. Okay, increase siya kasi positive siya, and then comma, ceteris paribus also. Okay, tenure. For every 1 year increase in tenure, there's a corresponding around $0.14 or 14 centavos increase in hourly wage, ceteris paribus. Okay, so those are the interpretations of these 3 variables. No? Now let's go here, guys. Ito medyo may weird na nangyari dito, no? Kasi may raised white. So ano tong raised white na to? Okay, let me show again our natin yung wage. Okay, tingnan yung wage data set natin. Okay, so gagawin natin dito structure, str, wage. Okay. So si wage natin, guys, as far as race is concerned, yan, factor siya, diba, with 2 levels. Female at saka race pala. Non-white at saka white. Here. Okay, factor with 2 levels, non-white at saka white. Alright. So, anong ginagawa dito? Pag may factor tayo, this is converted into what we call a dummy variable. Dummy. Okay, so buksan ko lang yung wage data set guys. No? Let me open this. May I suggest that you open it also? Let me just open it and then let me illustrate to you what happens with the dummy variable. What happens when you have a factor? And ano ginagawa ni R dun sa factor na yun? Do you still want me to explain this, guys, or alam niyo na to? Wala si Ina at saka si Papayos na yata sila mag-out, no? Okay, Ina, Richard, Samya, are you familiar already with what happens dun sa dummy variable kapag factor?
The pricer, yung based sa experience before, depende sa characteristic ng data. Hindi kasi siya pwedeng i-insert directly as variables. Parang tinatransform siya ng, lalo na yung data na hindi pwedeng i-rank and then numerical.
Okay. Okay, thank you. Chard, how about Ina? Familiar ka ba kung anong ginagawa? Particularly ng R kapag dummy variable?
No, sir.
No, okay, sige. Thank you. Thank you. Samya?
No, then, sir.
No,
Sorry.
sige. Okay, that then I have a strong reason to explain, no? Okay, so alam natin na itong tatlong variables natin na itong si race, itong si gender, at saka si status, they are categorical variables, character sila. Pero this can be used as to classify. So kasi hindi lahat ng guys, hindi lahat ng character variables pwedeng gamitin na classifier. Example, address. Kung may address ka dyan. So you have 500 different observations, iba galing Makati, iba Caloocan, address yun, specific yun. Ha? So does it make sense to use that as a classifier? I-classify natin yung address nila. Paano kung magkakaibang address sila lahat? So 526 levels, magkakaibang address kasi sila. So it doesn't make sense, no? Hindi lahat ng character variables pwedeng gawing factor. Ang ginagawa lang na factor, yung pwedeng gawing classifier. Kunyari ito, no? Si race, white siya at saka non-white. Okay. Now, ang ginagawa ni R, yung isa dito gagawin niyang benchmark or reference. Tulad ko ha. Gagawin niyang benchmark or reference variable. Okay, ano ibig sabihin ng reference or benchmark? It will be classified as 0. 0 siya. Okay? Tapos yung isa ang gagawin niya 1. Okay, so yung race guys, dalawang level siya, di ba? White at saka non-white. So ang question, we will have to convert this into a dummy variable. Yung dummy variable guys, ang values lang niyan 0 or 1. Okay, ang tanong, sino yung 0, sino yung 1? Ang ginagawa ni R, ina-alphabetize niya, tinitingnan niya kung sino yung unang mag-a-appear, kung alphabetically ito. No? So si non-white, mauuna siya kasi N2 eh. Si white, mahuhuli ito, di ba? So ang gagawin niyang 0, guys, ang gagawin niyang 0 is si non-white, no? Si non-white. So ito gagawin niya tong white. White yung gagawin niyang 1, si non-white gagawin niyang 0. Okay, so this is what happens, guys. Ito yung nangyayari sa backdoor ni R. If this is equal to white, then if you fix ko to kasi kakapit ko pababa, I'm just going to fix this along the row. If this is equal to white, then comma 1, otherwise 0. Yan. So notice ito white to, so 1 siya. Happy down po. So lahat ng non-white naging 0. So this is what we mean by dummifying. Okay, i-replace na ng 1 or 0. Ganun din dito sa gender. So sa gender guys, si female mauuna, no, alphabetically. So ang gagawin niyang benchmark si female. Gagawin niyang 0 to. So ang gagawin niyang 1 si male. Okay? So yung 0 guys, yun yung benchmark ha. Now that's very important kasi pag in-interpret natin, explain natin mamaya kung ano ibig sabihin ng benchmark. So this is equal to if, actually guys, pwede natin i-copy ito. Then this is civil status. Dito, ang married 0, ang single is equal to 1. So pwede ko na i-copy ito dito. Yan. Alright. Female, so dapat 0 siya. Single, so 1 siya. And then copy this down. Okay, hello. Simple na lang. There. Okay, so what happened was, yung categorical variable na to, pinalitan niya ng dummy variables. Okay, si race, ginawa niyang 0 yung unang alphabetically mag-a-appear, si non-white. So ginawa niyang 0 to. Therefore, ang lalabas na value will be about white. Okay, kasi si white yung 1. Dito naman, si male, ang gagawin niyang 1. Okay, if you notice, this is female. So, female, so 0 siya. No? So, male, 1 siya. Ganun din si single. Okay, so when we regress this now, magagamit ni R yung mga values na to, 1 or 0, parang naging numeric na siya. Now, take note that the dummy variables, dapat, the number of dummy variables, it follows yung k minus 1. K minus 1 din. Ano ibig sabihin yan? Okay. Yung k is the number of levels. No? Number of levels. Okay. So, kunyari guys, meron tayong yung kunyari status. Example lang to Kunyari frosh, senior, junior, sophomore, kunyari yan yung natin. Tapos ulitin ko na lang, soft, junior, senior, frosh, okay. Circle, okay, tapos senior, random lang, no? Random. So example lang to. Now, this variable status, how many levels does it have? Yung levels niya is ilan? Frosh, sophomore, junior, senior, 4. Senior. 4 yung levels niya. Okay? Therefore, ilan yung dummy variables nito? Ang dummy variables nito will be, ilan siya? Dummy variables will be equal to, since 4 yung levels niya, 4 minus 1. So 3 lang dapat. 3 lang yung dummy variables na i-introduce. Now, if we're using R, ito lang po pa. If we're using R, anong gagawin ni R dito? I-convert niya tong status variable na to into 3 dummy variables. Kaya anong gagawin niyang benchmark? If you alphabetize this, frosh, junior, sophomore, senior, ang mauuna si frosh. Therefore, siya yung magiging benchmark, siya yung magiging 0. So the rest will be, ang susunod si sophomore, okay, si junior, and then si senior. Okay, so ito yung magiging ang benchmark variable natin, ang reference variable. In other words, yung gagawin 0 will be frosh kasi si frosh yung yung alphabetically ng una. Okay, so again, ang nangyari dito, if this is equal to this, and then if you fix ko yung row na to, if that's equal to that, then tapos ito pala, if you fix ko yung line na to, I'm going to fix the column para hindi siya aalis sa column na to. If this is equal to that, then anong gagawin ng value? 1. Okay? Otherwise, ano mangyayari? Otherwise, 0 siya. Oops. Mali. Hindi ko lang i-formula para mas mabilis guys. No? Sorry kasi mas ano pa kung i-if ko eh. So ito guys, si Frosh, hindi naman siya sophomore, hindi naman siya junior, hindi naman siya senior. So ang lalabas, 0, 0, 0 siya. So kapag 0, 0, 0 siya, ibig sabihin nun, alam ni R na, ano yan? Frosh siya. How about si senior? Hindi sophomore yan, hindi junior, senior siya. 1. So junior is 0, 1, 0. Sophomore is 1, 0, 0. Okay. So in other words, guys, we were able to capture lahat ng levels ng factors natin using just 3 dummy variables. Okay? Hindi na natin kailangan maglagay pa ng Frosh na column. Otherwise, guys, we fall in what we call a dummy variable trap. Magkakaproblema yung model natin pag magsasama pa tayo ng isang dummy variable. Magkakaroon tayo ng multicollinearity. Okay, so just take note of that. No? Pero ang mabuti naman guys sa R, hindi na natin kailangan i-convert siya. Pag ginawa natin as factor yun, automatically siya na magsasabi ng ano. Siya na maglalagay kung ano siya, kung sino yung benchmark or reference. Okay, siya na magko-convert into a dummy variable. Okay, pause muna ako guys. Clear ba yung explanation natin? Clear so far? Paki-chat naman please kung clear. Yung concept ng dummy variables. No? Ginagamit natin yan pag yung variable natin character and we're going to use it as classifier. So manually, pag nag-Excel tayo, ganito gagawin natin. We have to make this into this one. Kasi hindi naman mababasa ng Excel yung character na ito eh. Okay, we will replace this one with ito. No? And then, mariread na niya. Okay, let's take a look at what happened. Alright, dun sa model natin, okay, so alright, what happened here? Saan yung model natin? Okay, dito na tayo kay ano, no? Dito na tayo kay gender. Take a look at gender guys. Si race pala, race white. So dito, in order to avoid confusion, linalagay dito ni R, race white, ibig sabihin, you interpret this as white in reference to your benchmark. Sino yung benchmark natin dito? Di ba si non-white? Bakit naging non-white yung benchmark natin? Kasi alphabetically, tinignan ni R kung sino mauuna, non-white. So si non-white will be equal to 0. So si white ang magiging equal to 1. So what's the meaning of this? Ang ibig sabihin nito guys, on the average, I hope you're jotting down notes, on the average, white employees tend to have, on the average, 0.1096, okay, 0.01 or 0.11 rounding na lang, $0.11 more than their non-white counterparts, comma, ceteris paribus. Okay, so you will interpret this now in relation to your benchmark variable. Okay, so in-interpret natin guys si white in relation to our benchmark variable, benchmark level, which is non-white. Okay, so ganun natin i-interpret yan. Now, of course, hindi natin masasama yan kasi ito, okay, ito kasi guys, hindi siya significant. But assuming this was significant, then ganun yung ano natin pag-interpret natin yan. Okay, how about this gender male? So, similarly guys, on the average, male counterparts receive $1.76 more than their female counterparts, comma, ceteris paribus. And this one, guys, is physically significant at 0.1%. Okay, so ang sinasabi dito, on the average, yung mga male employees, mas mataas yung hourly wage nila compared to their female counterparts. Okay? Kaya ang question dyan, meron bang discrimination? Kasi bakit on the average mas malaking si male, no? Bakit mas malaking yung hourly mas malaki by 1.75, no? Eh hindi ito yung average ni male, guys, ha, ng hourly wage ni male. This is the the average of the yung marginal na lamang, marginal advantage of male over their female counterparts. Okay, ceteris paribus. And then on the other hand, si single, okay, on the average, assuming it's significant, on the average, single employees tend to receive $0.46 less compared to their married counterparts. So mas maliit yung yung average na hourly wage, may lamang si married compared to the single employees by 0.46 ceteris paribus. Okay? So on the other hand, number of dependents, for every one child increase in the number of dependents, there's a corresponding around $15 increase, $0.15 increase in hourly wage, ceteris paribus. However, this is not significant. Okay? All right. Clear so far, guys? Chat naman please kung clear yung interpretation natin. No? So ang importante din dito, ang bago dito yung yung factor natin, si race white, gender male, civil status single. So sa R, guys, madali naman interpret kasi sinasabi naman niya kung kaninong value to. And then dapat alam natin kung sino yung benchmark. Okay, paki-chat please kung clear so far or may questions dito sa interpretation natin dito.
Question, sir.
Yes, sir. Okay.
Yung lalabas dito sa column for independent variables would be yung reference lang, sir, no? Kunwari earlier when we have 4 types na categorical, yung nilagay natin na 1 or yung reference lang ilalabas dyan.
Yes, I get your question. So sige, kunyari magbibigay ako example dito. Suppose we have a factor, no? Tapos 5 levels siya. So ang levels niya A, B, C, D, and E, no?
Yes, sir.
Ito yung levels siya, no? So pag ginan natin as factor kay Aryan, ano mangyayari? Titingnan niya alphabetically. Sino yung pinaka first mag-occur sa alphabetically, no? So si A. Therefore, si A yung gagawin niyang benchmark or reference level. So ang lalabas, guys, ang lalabas na result dun sa regression is sabihin natin ang pangalan ng variable var. So var B, and then var C, and then var D, and then var E. Ito yung lalabas sa regression output natin. Diba? Hindi lalabas si A kasi si benchmark si A yan. But whatever you get here, kunyari var B, this should be interpreted in relation to A. Kunyari, positive yung positive yung parameter, yung value. So sasabihin natin na si B receives whatever that, let's say B1 more than A. Ganun din kay C, kay D, at saka kay E. And as yung question nga Richard, ang lalabas lang, yung lang guys, yung mga hindi benchmark. Okay, di ba dito ang benchmark natin dito si non-white. Kasi si non-white ang mauuna alphabetically. So ang lalabas lang dito race white. Okay, dito naman ang benchmark si female, so ang lalabas lang gender male. Isa lang kasi sabi natin guys, if there are 2 levels, there will only be one dummy variable. Ito, 5 levels, ang lalabas lang 4 na dummy variables. So si var B, var C, var D, and var E, and it will be interpreted in relation to A. No? Lahat sila. Okay? Chart, nakuha yung information.
Yes, sir. Yes, sir. Yung may next pa, sir. Sorry.
Sige, go ahead.
Yung ibig sabihin, sir, kunwari yung sample natin yung var, yung 5 variables, no, yung dummy apat.
Isang variable lang to, no? Isang variable.
Sorry. Isang
Pero 5 levels. Pero magiging 4 na dummy variable siya.
Apo.
Okay.
Kunwari, sir, yung dummy variables natin na 4, although I can try naman din. Yung significant, hindi significant yung let's say 2 or 3. Doon sa model na parang yung final model, can I exclude yung not significant?
Hindi. Kasi sa model mo, ang variable mo pa rin talaga, si ano pa rin. Sa model mo, isasama mo pa rin yan. Ngayon, magkakaiba na lang sa interpretation yan, which i-discuss natin yan in greater detail. Chart, pag pumunta tayo dun sa pag diniscuss natin more deeply itong factors na to, itong categorical variables. Kasi magkakaroon ng variation dun sa pag-interpret niyan.
Okay.
Maganda kung meron tayong example talaga. No? I'm going to give that. No? Kasi common yan eh. Kasi nangyayari na but there are, let's say, ganito, 5 levels yung variable natin. So which means there will be 4 dummy variables. No? So good question yun na paano yung pag binodel natin to? Isasama ko ba si kunyari si var E at saka si var D? Hindi siya significant. Ang significant lang si var D at saka si var C. Paano yun? Paano yung model? Yung model mo will still be just var. Okay? Si var pa rin. No? Okay. Magbibigay ako ng example. Okay. Pero magbibigay ako ng example chart pag pumunta na tayo dun sa
Okay, sir. Okay lang, sir.
Okay, so we will siguro by next meeting or next meeting, definitely we will tackle that.
Thank you, sir. So to conclude, sir, to reconfirm. So example dito sa model natin na nasa left side.
Yeah.
If I'm going to finalize yung model, kunwari, dapat para-pareho sila ng significance. So kung magda-drop ako ng variable, dapat yung pasok, kunwari, if it's 5%, lahat ng significance sa 5%, although all those variable na nag-exceed or hindi significant at 5%, i-drop ko sila sa lahat.
Correct. Pero ganito kasi magsi-stepwise regression tayo. Hindi natin siya pwedeng i-drop lahat, no? We will have to, ito na yung next step natin. So ang final model ba natin, tatanggalin na natin lahat? Hindi. Because the proper way is to do stepwise regression. Iisa-isa natin tanggalin yung mga insignificant, which I'm going to show you in a while. No? Okay, pero pupuntahan natin ni Richard yan. Pero ano yung muna guys, anong ibig sabihin nitong negative 3.38? What is the meaning of this?
Meaning, sir, pag wala kang education experience, walang mas mababa.
Okay, correct, no? So itong negative 3.38, 39, although pragmatically or practically hindi siya pwedeng i-interpret, no? Hindi siya pwedeng i-interpret kasi wala namang hourly wage na negative, di ba? But just theoretically, ano ibig sabihin itong negative 3.39? It means that this is the average hourly wage of an employee that has no education, 0 years of education, 0 years of experience, 0 years of tenure, no dependents, okay, no dependents, who is non-white, female, and married. Tingnan nyo. Tingnan nyo yung interpretation na iba na, no? Ulitin ko yan, guys. Ang ibig sabihin itong negative 3.38, this is the average hourly wage of a person who has 0 education, 0 experience, 0 tenure, 0 number of dependents, who is also non-white. Bakit non-white? Kasi remember guys, ang intercept is that value of your dependent variable when all your independent variables are equal to 0. Di ba? Ano ibig sabihin ng race is equal to 0? Di ba non-white yun? Ano ibig sabihin ng gender is equal to 0? Di ba female yun? Ano ibig sabihin ng civil status equal to 0? Di ba married yun? Di ba? So when you interpret this now, itong intercept na to, you will have to incorporate that. So negative 3.39 average hourly wage ng isang tao na walang edukasyon, walang experience, walang tenure, walang number of dependents, who is non-white, who is female, and who is married. Okay, pause muna ako guys. I'll allow you to think about that for a few seconds. Okay, and then please paki-chat guys kung naintindihan or if you want me to repeat the explanation. Okay, good. Thank you, Samia. Thank you, Ina. Thank you, Chan. Okay, clear yun ha? Notice, sinama natin guys. Ginawa natin is equal to 0 lahat ng independent variables natin. Kasama yung categorical. Kasi may ibig sabihin na race is equal to 0, it means non-white yun. Diba? Kasi ang benchmark natin dito, yung ginawa nating 0, non-white. Ang benchmark natin dito, yung ginawa nating 0, si female. Ganon din dito, si married. Okay, so when we interpret the estimate, we are including the factors. Yung factors natin na race, gender, at saka yung civil status. Ang maganda nito guys, kung merong levels ng yung tinatanong ni Richard kanina. Paano kasi lalabas dito yung var B, var C, var D, var E. So paano yung modeling natin yan? Alright, so what will be our final model? Okay, assuming guys na, pero mali ito na tatanggalin natin lahat ng natin insignificant. No? So ang magiging model natin is, sulat ko lang dito, hourly wage is equal to, okay, so ano muna, no? Ano muna natin yung mod 2 na to, no? Mod 2 coefficients. Okay, so para copyhin ko na lang, intercept, okay, hourly wage is equal to, ito yung intercept natin, Control C, Control V. So plus, ang significant natin, education. This one, Control C, Control V times education. And then plus, open natin C. Sabihin natin guys na ang pinili natin level of significance is 10%. So papasok si experience. Assume na lang natin. So this one, Control C. Times experience, okay, and then plus si tenure. Tenure is this one, Control C, Control V times si tenure, Control C. Tenure, and then C plus 1.7 dito times gender naman. So madali na guys i-interpret to. Kunyari ang tanong sa atin, ano yung average na hourly wage ng isang tao na may ganitong education, may ganitong experience, na may ganitong tenure, tapos male siya. Okay? So pag male, anong gagawin natin? Gagawin natin equal to 1 to. Di ba? Kasi, di ba, pag male, 1 yan eh. So we will replace this by 1. Pag female, we will replace this by 0. So ganun lang yun. Parang yung question ni kanina ni ano, ah, wala, ni Richard, no? So kunyari ang tinatanong sa atin, ano yung magiging kunyari hourly wage nito ni person C. So kapag si person C ang hinahanap mo na hourly wage, gagawin mong 0 to, si B, si D, at saka si E. Ang matitira na lang yung variable ni C. Okay, but we'll have an example of that, don't worry guys. Okay, ito kasi ano lang, 2 levels lang, so mas madali lang. No? Okay, so that will be our model. So we can now predict hourly wage given the education, given the experience, given the tenure, given the gender. And notice that ang lalabas dito guys, ang lalabas dito sa model na to sa hourly wage will be ano? Pag male, makukuha natin. And then, ang makukuha natin guys dito yung sino? Non-white at saka married. Bakit non-white at saka married? Kasi hindi pumasok guys yung civil status at saka yung race. Hindi pumasok sa model natin. Okay, hindi pumasok yung race at saka yung civil status sa model natin. Therefore, naging 0 siya, di ba? Naging 0. Ano implication nun? Ibig sabihin nun, walang kinalaman guys whether white siya or non-white. It does not matter. Hindi nagko-contribute yung race. Hindi rin nagko-contribute yung civil status dun sa pag-determine ng hourly wage. Kasi insignificant na siya. So, yung race as a predictor and civil status as a predictor did not matter. Walang distinction kung white man siya o non-white siya or single man siya o married siya dun sa pag-compute ng hourly wage. Okay? Clear yan guys? Clear? Chat naman kung clear so far guys. Okay, thank you, Ina. Okay, Samya, thank you. Chard, okay, good. Sino nawala? Si Ina, no, na isa at saka si Ayus nawala. Wala sila. Okay. Let's continue with this, guys. Right. By the way, guys, dito sa okay, meron tayong tinatawag na when we're comparing models, model 1, model 2, we need to determine kung sino mas maganda. Si model 1 kanina, di ba si model 1 kanina yung isa lang yung predictor natin. Simple linear regression lang siya. Si model 2 naman, 7 yung regressors natin. Okay? So we can make use of what we call the AKA-IKI. So this is the AKA-IKI. AKA-IKI information criterion. So ginagamit to guys in order to compare models. So mod 1, right? And then comma AIC mod 2. Okay, let's compute for the AKA-IKI information criterion. Tingnan natin guys kung sino yung mas dito na siya, no? Okay, so lagay ko na lang dito. AIC, then mod 1. And then there's also another one, BIC, Bayesian Information Criterion Model 2. So saan ginagamit ng AIC at saka BIC na to? We use this in order to determine, tanggalin ko nga siya dito. Dito ko ilagay sa ilalim. Ito na pala. Ito na lang. We use this in order to compare which model is better or not. No? Si model 1 natin, yung kanina, yung only one independent variable. And there's a name for that. We call it restricted. Ito yung restricted model. Bakit restricted? In relation to the other one, model 2, with 7 independent variables, unrestricted ang tawag. So yung mas konting variable, guys, mas konting predictor, siya yung restricted. And then mas maraming predictor, siya yung unrestricted. Okay, so if we compute for this, all right. So, AKA-IKI na model 1, 277, versus si model 2, 2640. Now, the decision rule is the lower the Akaike information criterion, which is a measure of information loss, the better. So in this case, in model 2, the one with 7 independent variables is better compared to model 1 based on Akaike. Right? Diba? Also based on Bayesian information criterion, mas maganda din si model 2. So that's one parameter. No? Another parameter is, what do I mean by parameter? We are comparing, guys. No? Kino-compare natin kung sino mas maganda, si model 1 o si model 2. One is AIC, yung Akaike. Another one is adjusted R-squared. Take a look at the adjusted R-squared of model 2. Ito yung adjusted R-squared. 36%, guys. 36.2%. As compared to model 1 na 16% lang. So in terms of being able to explain, yung explanatory power, no? In terms of being able to explain the variation in your dependent variable, mas magandang dihamak si model number 2, the one with 7 independent variables. Kasi 36% ang kaya i-explain, si model 1, 16% lang. Okay? So based on AIC, mas okay si model 2. Based on adjusted R-squared, mas okay si model 2. And there's a statistical test, guys, that we can use in order to statistically test kung sino mas maganda si model 1 or model 2. So we can use the ANOVA, analysis of variance. Okay, so nag-a-analysis of variance tayo ni model 1 and model 2. So pwede naman magkabaliktad dyan. So gawin na lang natin model 1 and model 2. Remember guys, si model 1 natin, in this case, is the one with yung simple linear regression natin. Isa lang yung independent variable natin. Si model number 2 is 7 independent variables. Now, this is a statistical test. The null hypothesis is the restricted model, yung the one with lesser independent variables or predictors is better. So mas maganda ba si model 1 yung mas konting predictors? Let's see. Run natin analysis of variance. So it gives us this, guys, p-value. Si model 1 natin, education lang yung predictor. Si model number 2, lahat, no, yung 7. And then it turns out that the p-value is practically 0, significant at 0.1%. So ang conclusion natin, guys, we reject the null hypothesis that model 1 is better. So ano sinasabi sa atin yan? Reject natin yung hypothesis na yan na mas maganda yung restricted model, mas maganda yung unrestricted model. In this case, mas maganda si model 2. Mas maganda yung mas maraming predictors. Okay? Clear guys yung ANOVA so far? Okay ba? Pakichat naman please. Okay, good. Thank you. Thank you. So statistical test guys, ha? ANOVA. So ano yung ginamit natin na basis of comparison? Number 1, adjusted R-squared. So mas mataas si adjusted R-squared, mas better siya. But guys, may caveat tayo dyan, ha? It doesn't mean na in all cases, it doesn't mean that pag mas mataas si adjusted R-squared, mas maganda na siya. We will have examples na mas mababa si adjusted R-squared, better siya compared to the other model. Number 2, yung AIC. The lower the AIC, the better. So, generally, ganun guys. But there will be some instances na mas mataas si AIC, mas maganda. Okay. And the most powerful comparator guys is yung statistical test natin na ANOVA. So this is a statistical test. So we're testing kung sino ba mas maganda yung model natin. Ang null hypothesis natin dito is that the restricted model is better. Okay, so in this case, we reject that null hypothesis. No? We reject the null hypothesis that model 1, which is the restricted model, is better. So mas maganda si unrestricted, si model number 2. So in all cases, guys, mas okay si ano natin, mas okay si model number. Okay, so consistent siya. Okay, now let's move here, guys. Okay. So natapos sabihin model natin, hindi pa. Okay. Let's go here. So what do we do now? After our model, guys, okay, do we just have to delete or remove the insignificant variables? Hindi, guys. Hindi. Kasi we will have to do stepwise regression. Dalawang klaseng stepwise. Forward na stepwise at saka backward na stepwise. Ang ginagawa, guys, sa forward stepwise regression, isa-isang linalagay yung variables. Isa-isa until you come up with the best model. Okay, sa backward naman, linalagay lahat muna ng mga predictors and then isa-isang tatanggalin. Okay, so here, we will have to remove one variable, one at a time. Hindi pwedeng sabay-sabay. Okay, so we're going to create now another model, model 3. So this model will now be not 7 predictors but only 6. Ang tanong, sino yung tatanggalin? The rule is, you take a look at the t-value, ito. Okay, and then remove the one that has the lowest absolute value ng t-value. Okay, so disregard the sign. Yung pinakamaliit na t-value, yan ang pinakamaliit, guys, na explanatory power. No? Okay, so syempre ang pipiliin na lang natin, guys, dito kasi yung mga significant malalaki siya. 11, 3, okay, ito 6. Okay, so ang natitira, guys, yung mga significant 0.257, 1.5, and 1.34. So ang pinaka-lowest dito is yung raise, 0.257. Therefore, what are we going to do? We're going to delete this raise. Okay, maggagawa tayo ng panibagong regression model and we're going to remove yung raise as a predictor. So we go here now, dito na tayo, creating model 3. Ang leaving variable natin, yung paalis, is raise. Okay, because it has the lowest absolute t-value. Ito yung raise natin. Okay, yung raise siya. Therefore, so model number 3 now is linear model, hourly wage, regressed on all your predictors except tinanggal na si race. Wala, andyan si gender, andyan si civil status, andyan si number of dependents. Wala na si race. Another way to write this is LM, hourly wage, tilde, dot, and then minus race. Data is equal to wage. Okay? So let me run, ito naman i-run to model 3 na to. And then summary. So ito na yung model 3 natin. So actually, guys, paulit-ulit lang to. No? So iterative naman tong process na to. Okay, so what do we have here? We now have this model number 3. Okay, ano muna tayo? Overall goodness of fit. Okay, yung overall goodness of fit natin, p-value is less than 0.05. Ibig sabihin, at least one of these parameters, B0, B1, B2 hanggang B6 is equal to 0. At least one of them is not equal to 0. However, guys, tinan natin adjusted R-squared. Ito, 36.31. Yung isa kanina, ilan yung adjusted R-squared niya? Yung model number 2 natin, 36.19. So, mas maganda yung model number 3 natin in terms of adjusted R-squared. Right, guys? Kasi mas mataas yung variance na kaya i-explain ng model natin. 36.31% compared to model number 2, 36.19%. Okay. Next. Tingnan natin, guys, yung mga individual tests ng parameters natin. Intercept is significant. Okay. Education is significant. We know how to interpret this. For every 1 year increase in education, there's a corresponding $0.57 increase in hourly wage ceteris paribus. So experience, ganun pa rin. No? Significant at 10%. Tenure, gender, significant. Ano ibig sabihin ng tenure guys na 0.14? So for every 1 year increase in tenure, 1 year increase in tenure, there's a corresponding $14 increase in hourly wage, ceteris paribus. So experience, assuming that it's we use as 10% significance level, so significant din siya. So for every 1 year increase in experience, there's a corresponding 2 centavos increase in hourly wage, ceteris paribus. Pero kung ano guys, kung 5% yung significance level na ginagamit natin, hindi papasok sa experience. Alright, ito naman si gender male. Ganun din, alam natin to, significant to. So on the average, male employees receive $1.76 more than their female counterparts, ceteris paribus. Okay? And this one, yung civil status, hindi siya significant. Number of dependents, hindi rin siya significant. Okay, but if this was significant, ano ibig sabihin nito? On the average, single employees receive 46 cents dollars, $0.46 hourly wage less than their married counterparts, ceteris paribus. Okay? All right. So just like how we interpreted it before, ano naman to intercept? On the average, okay, people with employees with no education, no experience, no tenure, okay, who are female, okay, dito papasok din na ano na hindi naman significant to, no? Kaya baliwala na to. Receive on the average negative $3.3 hourly wage. Okay. All right. So in terms of R adjusted R squared, mas okay to. In terms of AIC, okay, run natin ulit to, no? Okay, model 3 is preferred compared to model 2. So model 3 na 6 lang yung independent variables, tinanggal natin yung race, mas okay siya compared to model 2 with 7 independent variables. But the acid test really guys is the ANOVA. So here, ang restricted model natin is model 3. Medyo nabaliktad to kanina. No? Si model 3 yung restricted model natin kasi si model 3, 6 na lang yung predictors natin. Si model 2, yung 7 yung predictors natin. So let's run this. So what will happen here? Okay. P-value is 0.79. So we fail to reject the null hypothesis that our restricted model is better than the unrestricted model. Mas maganda si restricted model guys. Mas maganda yung 6 na lang yung predictors natin compared to the one with 7 predictors. Okay, so I hope this is clear. So in terms of adjusted R squared, in terms of AIC, in terms of the ANOVA test of variance, no? Mas okay si model 3, the restricted model, the one with lesser predictors. Okay, so uulit lang yung proseso guys. Okay, so we don't remove all. So magtatanggal na naman tayo ng isa dito. No? So ang candidate natin si number of depth. Number of dependents. Since it has the lower absolute value. So just ignore the negative signs of p-value. Ito 1.58, ito 1.33. Ang leaving variable natin si number of dependents. Okay, if we run that, umulit lang to, no guys? So we're now creating model number 4. Tinanggal natin dito yung number of dependents, right? Hourly wage, regressed on education, experience, tenure, gender, civil status. Lilima na lang. Okay, so if you run this, yan. Okay. All right. You notice guys na si experience hindi na significant. No? Tapos ang naging significant at 10%, barely significant at 5% si civil status. Okay, and what happened to the adjusted R-squared? Lumiit siya. 36.21%. Kung kanina, 36.31%. So in this case, guys, if we're going to base it on adjusted R-squared, mas maganda yung previous model natin, model number 3. Kasi mas mataas yung adjusted R-squared niya. But let's take a look. No? Before we go to AIC, you know how to interpret this, di ba? Alam na natin na ma-interpret to. Okay, so si experience hindi na siya significant. Si civil status kanina hindi significant, ngayon naging significant siya at 10%. Okay, so medyo nabago. That's why it's very important, guys, to do stepwise regression kasi minsan pag hindi siya significant dun sa unang natin pag model, nagiging significant siya later on because of the interplay of the variables. Alright? So AIC naman, sino mas maganda? Si model number 4 o si model number 3? Model number 4, guys, 26.38. Model number 3, 36.38.8. So halos magkapareho lang siya. Barely lang, ano? Very minimal yung difference. So hard to determine, guys, kung based on AIC, mas maganda nga si model 3 or model 4. But if we're just going to base it at face value, mas maganda si model 3. The one with 6 independent variables as compared to the one with 5 independent variables. But then again, the acid test, guys, is ANOVA. Okay, si ANOVA natin. Si model number 4 natin, ito yung 4 independent variables. Ito yung restricted model natin. Si model number 3, yung 5 independent variables. Ito yung unrestricted. Okay, run natin. Okay, p-value 0.184. So, we failed to reject the null hypothesis that the restricted model is the preferred model compared to the unrestricted. So, mas maganda si restricted. Mas maganda yung 4 lang na independent variables. Okay? Compared to the dito sa 5 independent variables. Wait, 1, 2, 3, 4. Mali ito, sorry guys. Sorry guys, mali ito. There should be 6 independent variables versus 5. Okay. Si model 4, si model 3 natin, si model 1 kasi, isa lang, di ba? Si model number 2, 7. Si model number 3, 6 yung independent variables. Si model number 4, 5 na lang. So mas maganda si model number 4 based on the analysis of variance. So in terms of adjusted R-squared, mas maganda si model number 3. In terms of AIC, mas maganda si model number 3. But then again, sabi ko kanina guys, hindi foolproof yung adjusted R-squared at saka yung AIC in determining whether a model is better. It's one of the parameters that's used. Okay. And then lastly, guys, iisa na lang naman ito. Siyempre, ito yung hindi significant, 1.558. Kahit na gawin natin ang significance level natin at 5%, okay, mas mataas pa rin to si civil status compared to experience. Si experience ang pinakamababang T-stat, no? So tatanggalin natin si experience. Okay? So we remove experience. So model number 5 na tayo, no? Model number 5, education, tenure, gender, civil status. 4 na lang. So 3 na yung tinanggal natin. We already have removed 3 independent variables. So let's run this. Okay, let's take a look. All our variables are already significant. So yung stepwise, guys, hanggang last step, dapat significant na lahat ng variables natin. Okay? Then we can now interpret this. Lahat sila significant. And you see the adjusted R-squared is actually lower, 36.04. Kasi kanina 36.21 yata. Ito 36.04. Okay, pero overall goodness of fit, okay siya. And then individual test, okay siya lahat, significant na. So our final model will be hourly wage is equal to negative 2.16 plus 0.53 times education plus 0.15 times tenure plus 1.7 na gender plus negative 0.68 na civil status. Okay, that would be our final model. Okay, next meeting, titingnan naman natin yung paano kung gusto natin malaman yung female at saka yung married. We will take a look at that. Okay, sandali ha. Model 4, Model 5. Check natin guys based on AIC para matapos ito. Based on AIC, mas maganda si model number 4, no? Yung mas maraming predictors. Pero sabi nga natin, this is just one of the ways we check. Ang pinaka-ano dyan, yung ANOVA natin, 0.1198. So model number 5, which is the restricted model, is better. We fail to reject that the restricted, the one with the lower, ito, yung restricted natin, si education, tenure, gender, civil status. So that's the one with the lesser number of predictors. Ito yung restricted model natin. So we fail to reject that this is the preferred model. We fail to reject it. Na ito yung preferred model. Ito nga yung preferred model, guys. Okay? And then we can print, guys, yung ito Stargazer. I don't know if this kung nasama ko dyan. Kung ano, guys, pakikopya na lang yung package natin ng Stargazer. And then ipapaprint natin yung module 5. Okay, there. So mas magandang output to compared to yung kaninang summary, ano? Okay, this is it's better to use this. Kasi makikita natin yung value ng ano natin, value ng yung parameter natin, 3 stars. This is your standard error, no? Ito naman yung 0.154 standard error to. Gender 1.721, and then this one civil status, and then ito yung intercept natin. The ones in the parentheses are your standard errors. 1047. Ito yun. Pakita ko lang ha. Ito guys, no? Ito yung standard error. Here. Education 0.047. So linagay siya dito sa Stargazer ng Model 5 and type is equal to text. Okay. So andito yung observations, andito yung R-squared, andito yung adjusted R-squared. Standard error ng residuals, degree of freedom, F-stat, statistically significant, degree of freedom 1, 4. Ibig sabihin nito 4 yung predictors natin. Degree of freedom 2, 521. This is n minus k minus 1. Okay, and my notification dito na ang 3 stars, okay, ang 3 stars, it's less than 0.0, less than 1%. Actually, ano yan, dapat less than 0.1%. And Stargazer na kasi ito. Yun ang ginamit ng Stargazer. Okay, then we can also use this. Yung sa J2s natin, we can use the sum function ng Model 5. Another way to present, guys, your data. So nasa ano lang yan, nasa kung ano yung gusto nyo, whether to use the Stargazer method or the pero ibang ways pa, no? But we're just looking at the Stargazer and the J tools, making use of the SUM summary function na. Okay, this is a lot better than ito, no? Okay, questions so far, guys? Questions sa final model natin?
Hello, sir.
Yes, yes.
Question po.
Yes, sure.
Di ba, sir, yung stepwise natin, parang nabanggit nyo, it's parang increasing or padagdag ng variable. Meron
Forward yun, forward.
Forward siya.
May stepwise na forward, magsisimula muna one variable yon. Tapos isa-isang idadagdag, no? Isa-isang idadagdag hanggang ma-come up yung final model.
Okay, sir.
Sa ano naman sa stepwise na backward, ilalagay lahat ng predictors ng independent variables, isa-isang tatanggalin. So that's the difference. Okay?
Yes.
Did that answer your question, Chard? In fact, okay, let me go there now. No? Let me go there now. So leave muna natin tong diagnostics, guys. Ha? Kasi babalikan natin to next meeting. Titingnan natin yung kamusta yung model natin. Okay? Na may mga nababiolate ba na assumptions ng OLS? So here, ang gagawin muna natin, guys, ito yung stepwise regression dito sa dulo ng model natin. Okay. So method number 1 is forward regression. Ito yung sinasabi ko sa inyo. And we're going to make use of the OLS RR package. A very powerful package itong OLS RR. No? So in library natin, okay? So we're now doing the stepwise regression. Automatic na to. Kasi kanina, guys, inasa-isa natin di ba? Minanual natin. But we did that for you to appreciate kung ano nangyayari. No? When we understand what happens really in stepwise regression, hindi na tayo nag-example, by the way, ng forward kasi mas mahirap yun. Ang ginawa na natin yung backward. Kasi yung backward, as I mentioned, i-load mo lahat ng predictors and then isa-isa natin tatanggalin sila. Okay, so dito, guys, i-load natin si OLSRR. If you have not loaded this, i-install nyo yung package. Ito. Okay. All right. Then we will write our regression model. Okay, let's just call it model LM. Ito yung full model natin, guys. Okay, data is equal to wage. All right. And then alam natin yung shortcut, hourly wage tilde dot. All right. We're going to make use of this function in OLSRR. OLS step forward P. Ano ibig sabihin nitong P, guys? Ang ibig sabihin ng P dito, guys, ang gagamitin ni OLSRR na parameter is yung probability, yung P value. Dito, P enter. Ano ibig sabihin nun? Ipapasok niya one by one yung mga variables for as long as dapat yung P value niya should be less than 0.05. So, kailan magiging kailan pwedeng ipasok ang isang variable? Dapat yung P value niya should be less than 0.05. Okay? So, that's why sinasabi natin dito, yung title ko dito, forward regression using P values. Okay, so na-run nyo na na-load nyo na si OLS. I-run natin to, guys, one at a time. So model. So now here we have a model, no? Parang yung mod 1 natin to kanina na kasi ito yung full model natin. Okay? And then let's not run this, pareho lang naman to. Ano ko na lang to. Same lang yan. Okay, and then here we're creating an object called forward fit.p. No? So we're fitting a model here, forward to na stepwise regression. And then ang ginagamit natin anong ginagamit natin na basis para pumasok yung isang variable sa model is the p-value. Kasi may isang basis din yung AIC. Here we're using the p-value. Okay, so if we run this, guys, okay, medyo mahaba-haba itong generate niya, no? Okay. Number 1, pinapakita yung summary. Okay, tingnan niyo yung ginawa niya. Ang unang ginawa niya, variable entered. Ang unang pinasok niya, education. Ang R-squared na generate ng 16.48%, adjusted R-squared is 16.42. CP, guys, is a Mallows number to explain ko na lang next time to. No? And then AIC is 277 And then root mean square error, 3.37. So ang unang pinasok niya is education. And then, so definitely guys, yung p-value ng education na ito, yung pinasok niya, less than 0.05. So significant to. Ang susunod na pinasok niya, tenure. Okay, ano nangyari? Nung pinasok niya yung tenure, kasi forward na ito, di ba? Step 1, step 2, step 3, step 4. Nung pinasok niya sa tenure, tumaas yung R squared. Okay, adjusted R squared tumaas. CP Mallows number 54. This is a function of error, no? So the lower the CP, the better. AIC guys, 2685. Mas maganda kaysa model. First step natin. RMSE, 3.09. Root mean square error. The lower the better then. Okay. So second step. Third step, gender. Tumaas si R squared, tumaas si adjusted R squared. CP, bumaba. AIC, bumaba. RMSE, bumaba. And then yung fourth niya, civil status. Okay, so take note guys, pareho ito nang na-generate natin na result kanina. Pareho lang. No? Notice guys that the adjusted R squared is higher than the previous one. Okay, CP, Mallows coefficient is lower also, which is good. AIC, lower. RMSE, lower. Okay, so ito na guys yung ano, ito na yung final model natin. Okay, and then i-explain niya kung paano niya kinuha. Okay, paano kinuha? Kasi ito guys, ito lang to no? Yung summary lang binigay sa atin dito. But if we will ask R, ito guys, forward fit.p, 11 yung laman yan. Okay, so ipa-summarize natin to, no? Ipa-generate natin yung lahat ng nangyari. Okay, ito yung mahaba-haba. No? Okay, so take a look at this. Alright, summary lang pala to, no? Sorry. So ito lang kanina. Ito guys yung details, no? Okay, so we're creating this object, forward fit 1 dot p. Ito yung kanina, OLS step forward p. Yung LM model natin, yung model, P enter is equal to 0.05. Details is equal to 2. So, ibigay natin details. Okay? Run natin to. Ito medyo may katagalan ng konti. Run ko na. Alright. You can see that mahaba yung output. Kasi dinitali niya kung anong ginawa niya. Okay. So this is the forward selection method. Okay, we have 7 variables, independent variables to. Okay, we are selecting based on p-value, diba? P enter natin 0.05. So step number 1. Okay, ang pinili niya, education. Yun. Okay? So among the different choices, ang pinakamaganda sabi niya is education. Okay. Ano nangyari sa education na yan? Ang adjusted R squared natin, 0.163. So, ibibigay sa atin guys yung different measures. No? Ito yung mean absolute error, mean square error, coefficient of variation, Ramsey, root mean square error. Kino-compute niya yung mga errors, okay, bawat step. Ano yung ANOVA niya, guys? Ano yung ANOVA niya? Significant, 0.00. Ano ibig sabihin nito? Okay, this is our analysis of variance. 1 degree of freedom, DF1 to kasi isa yung predictor natin. Alright? So ang analysis of variance natin, okay siya. We reject the null hypothesis that beta null is equal to beta 1 is equal to 0. Okay, parameter estimate, guys, yun na yun. Parameter estimate, ito. Ito guys yung simple regression natin, di ba? Kanina. Significant ba si education? Yes. Pinasok natin siya kasi less than 0.05 yung ano niya. Okay? Alright, next. Forward kasi ito, forward selection number 2, dagdag daw si tenure. Okay? So ito yung mga steps, no? Okay, we will not go into this individually. And then andyan yung ANOVA. Okay, B0 is equal to B1 is equal to B2. Kasi dalawa na yung natin, predictors. And then we reject the null hypothesis that they are all equal to 0. Parameter estimates. Okay. Parameter estimates. Education, significant, less than 0.05. Tenure, significant, less than 0.05. So, nagpo-forward siya. No? Isa-isa niya pinapasok. It did not stop at step number 1 kasi nag-improve pa yung model natin nung nagdagdag siya ng tenure. Nag-improve pa nung nagdagdag siya ng gender. Okay? Significant ba si gender? Yes. Significant guys si gender. No? And then last step, plus 4 guys, civil status. Okay? Significant ba si civil status? Yes. Less than 0.05. Okay? So no more variables added. So nung nag-forward, forward stepwise regression, isa-isa niyang dinadagdag yung mga variables. And ang ano niyan, dapat guys, nag-i-improve over time. Hindi pa pwedeng magdadagdag ka, tapos magdi-deteriorate yung model mo. So that's the key for forward stepwise regression. Dapat pag nagdadagdag ka, dapat gumaganda yung model natin. At saka once na dinagdag mo na siya, hindi na siya pwedeng i-alis. You cannot remove that. Alright. So ito yung summary guys. And then ito yung kanina, inulit na ulit. Alright? So yun ang ano natin, yun ang unang forward regression natin using p-value. Ito naman guys, forward regression using AIC. So sabi natin kasi pwede ang gawin yung parameter yung P. Yung P-value dapat less than 0.05 or pwede nang gamitin to guys. No? OLS, step forward AIC. Okay? So ito, we're creating an object called forward fit.aic. Pero ang gawin natin guys, okay, sige, i-run muna natin to para you know what's happening. So dito AIC model guys, no? forward pa rin to us, step forward. Run natin and it will give us a summary. Yan. So notice guys, kapag AIC ang ginamit natin, 5 yung variables natin. Kasi ang ano niya, kailangan yung pinaka-lowest na AIC. Dito dinagdag niya si experience. Okay? Dinagdag na si experience, 2638. Okay, however, if we're going to take a look at this, guys, okay, tingnan natin dito. Details is equal to true. Let's take a look at this. Itong details is equal to true. I-plot muna natin sa delta. Plot natin si forward fit.aic. Let's plot this. Ito pala, sorry. Plot this. You see what happens here? Alright. What do we have here? A plot of your AIC. Kasi dito sa forward regression na to, ang ginagamit natin si AIC as a basis if the variable will enter or not. Forward to it. Okay, tingnan nyo guys yung AIC na to. Ito yung AIC. Ito yung step 1, 2, 3, 4, 5. Notice guys, education, sinama natin si tenure, bumaba yung AIC. Sinama natin si gender, bumaba yung AIC. Sinama natin si civil status, AIC went down. Hanggang ultimately, pinasok natin si experience, bumaba sa AIC. Pag dinagdagan pa natin ng isa to, tataas yung AIC. Okay, that's why nag-stop na siya dito. So that's what we do with the forward stepwise regression using AIC. May conflict siya guys, no? May conflict siya between the P enter kanina. Okay? Let me show that to you. Yung isama natin details is equal to 2 here. Okay, again, ito yung detalyado, no? Detalyado to. So isa-isa niyang ipapasok para yung kanina, binimeasure niya yung AIC. Hourly wage, 1, ibig sabihin nun, average lang to guys. Walang gagamitin na ano dito. Walang gagamitin na predictor. Ibig sabihin itong hourly wage is regress on 1 ibig sabihin, it's just regress on the average. Okay, parang ano ka lang, model ka lang na average yung gagamitin natin na ng hourly wage na predictor. Okay, ang sinasabi dito guys, ito yung mga candidates, no? Okay? So, ang sinasabi dito, alright. Pag ang ipasok daw natin si education, ito yung magiging AIC. Kasi AIC nga yung basis natin. Pag pinasok natin si race, ito yung magiging AIC. So, syempre, pipiliin niya yung pinakamababa na AIC. Okay? So, ipasok muna natin si education. It will generate the lowest AIC compared to kung unang ipapasok mo si tenure or si gender, etc., mas matataas yung mag-generate na AIC niya. So, unang ipasok sa education. Okay, pangalawa. So, pinasok na natin sa education, ano? Plus education. Ito na yung naging ano natin, naging AIC. Alright, so ito na yung model natin. Hourly wage. Next step, guys. Pag pinasok naman natin si tenure, ang AIC natin bababa, magiging 2685. Dito 2777. Pag si race ang pinasok natin, tataas pa nga, 2779. So obviously, sabi niya, ipasok niya si tenure. That's the next forward, no? Stepwise regression. So pinasok natin si tenure, ito na yung naging model natin, hourly wage, regression, education, plus tenure, and then ang AIC natin bumaba, 2685. Kanina, 2777. Okay, next. Sino susunod ipapasok? Pag pinasok natin si gender, etc., no? Ito yung mga comparators natin. So, ipapasok natin si gender. Kasi siya yung pinakamababang AIC na mariresult. Pinasok natin si gender, ito na yung model natin, education plus tenure plus gender. So, di ba forward, guys? Forward na stepwise regression. Bumaba yung AIC natin, 2643. Okay, again, stepwise number 4. Okay, sino ipapasok natin? Si civil status. Kasi siya yung mag-generate na lowest na AIC. So, ang sunod natin na ginawa, plus civil status. There. So, ang model natin, 4 na. No? Okay. Ang AIC natin, 2639 na yun. Alright. Now, may idadagdag pa ba tayo? Yes, idadagdag natin sa experience. Kasi bababa yung AIC natin. So, based on AIC, kung bababa pa si AIC, guys, i-ano natin, ipasok natin siya. So, dinagdag si experience, no? Ano nangyari? From 2638.6, naging from okay. Ito. Okay. From 2638.6 from 2643 gender civil status and then experience. No? From 2638.6, okay, anong gagawin natin? From 2639, okay, pag ipasok natin si experience, magiging 26.38. So, dapat ba ipasok? Yes, ipapasok. Kaya plus experience. And then, lastly, guys, okay, so kasama na sa experience, ano? AIC natin, 2638. Pag isama po sa number of dependents, magiging 2638.8. Hindi na, no? Hindi na, kasi tataas na yung AIC. So, ang final model natin, guys, no more value, variables to be added. Ito na lang. 5 yung predictors natin. Okay, and then let's take a look at our final model. Take a look, guys. Si experience dinagdag natin kahit na hindi siya significant. Okay, take a look at this, no? Kasi ang basis natin yung AIC. Alright? AIC. No? Pero kasi ang basis na natin ginawa natin AIC, so since bumaba naman yung AIC, ipasok pa rin natin yan kahit na even if it's not significant. Okay? So may ano may conflict, no? Usually guys, ang ginagamit talaga natin yung p-value. So that's why guys, we will prefer yung una, yung forward regression na na using p-enter is equal to 0.05. Okay, ito naman guys, backward. So halos pareho lang siya ng forward, pero well, ang difference guys, pabaliktad tayo. No? I mean, the codes will be just the same. So I leave you to explore this. No? Ito ginagamit yung p-value. P remaining, okay, kanina p-enter. Paano ba pasok? Dapat yung p-value niya 0.05. Ito paano magre-remain? Dapat 0.05 siya. So i-run lang natin itong details. No? The details. Alright? So ganun din to guys. Okay, candidate terms yung 7 natin na predictors. So okay. If you take a look at this, step 1. Ano daw yung variable? Backward elimination tayo, di ba? Backward na stepwise, no? Ano yung tatanggalin natin na na variable? Okay, ano yung tatanggalin natin? So, let's see here. Okay, candidate, we are eliminating based on p-value. So, una daw tatanggalin si race. Diba naalala nyo kanina, yan ang unang tinanggal natin yung race. Okay? So, pag tinanggal natin si race, guys, ito yung mangyayari, ito yung magiging, natin, model summary, ito yung ANOVA natin. Okay? Tapos ito na yung magiging mga parameters natin. Nung tinanggal natin si race. No? Alright? So ito yung mga variables natin. Okay? Ito yung p-value nila. Kasi one at a time lang. So may mga hindi pa rin significant. So dito guys, ano yung unang tatanggalin? Alam natin guys, ang susunod na tatanggalin is the lowest p-value, no? Which is 1.33. Ito yung susunod na tatanggalin yan. Kaya sabihin dito, ang susunod yan, no? X number of dependents. Tanggalin yan. Yan ang step 2 natin. Which is what we did a while ago, guys. Minanual nga lang natin. Ito, automatic siya. So yung ginawa natin kanina, guys, step by step, ginawa niya. Tapos mas complete pa, no? May model summary, may ANOVA. Okay, until such time na ito. Ito na yung final model niya, no? Intersect. Education, tenure, gender, male, civil status. Ito guys, yung natin, yung final model natin kanina. All the variables are significant. No? Okay, sabi niya, no more variables to remove. So, mga tinanggal natin, race, number of dependents, and experience, which is what we did a while ago. Okay, so final model, ulitin niya, ito yung parameter estimates. Right? Ito yung elimination summary, ito yung mga tinanggal niya. Okay, una yung race, number of dependents, and experience. And then may backward regression din na AIC, which will be the same as yung kanina, yung forward. So I will leave that to you guys. Okay, and then tingnan nyo rin guys, merong both, no? OLS, step model, both. Ano naman itong both? What is both? So both models, guys, okay, tingnan nyo to, no? A stepwise regression using p-values. Yung both, guys, pwedeng enter at saka remain. So pwede siyang, combination siya ng forward at saka ng backward. Okay? If we run this, guys, okay, usually, minsan, unless talagang may model na nakikita siyang dito, no? Ano nangyari dito? Nilalagay kong add or remove. Okay, so it's both forward and backward, no? Kasi may entering at saka may remaining. So dito uunahin niya muna, may ipapasok pa siya o may tatanggalin siya, no? So dito lahat ang nangyari, addition lang. So wala nangyaring both. Okay, kasi lahat addition lang. But there are instances na magdadagdag siya tapos magtatanggal. Okay, yun ang both, guys. Okay, and then this one, OLS step, all possible models. Okay, so I'll leave you guys to look at this. Lahat ng possible models, medyo mahaba-haba itong ano na to, no? Itong So hindi pa natin tinitingnan guys yung iba dito but I leave that to you since I'm sure you'll be able to decipher this. Look at this. Ito kasi both, no? Both P. Ginawa natin kanina yon. Okay, may details din siya. Tapos ito naman, both din pero AIC. Ito kasi both P ang ginamit. Ito naman both AIC naman yung ginamit. So dalawang methods ang ginagamit, no? Either P or AIC. Okay, and then ganun din po guys, both din to, no? Both AIC. I will not run that anymore. And then lastly guys, ito yung all OLS step, all possible. Okay, ito all possible. So tingnan natin ha. Medyo malaki-laki yung ano to. And then it will summarize, no? Kung ano yung mga yan. Okay. So lahat ng mga steps na possible guys, take a look. Medyo comprehensive siya. Okay. So anong pinapakita nito? Okay, index 1, 2, 3, 4, 5, 6, 7. Ilang steps to? Ilan yung possible na regression methods? Lahat ng possible is 200. Saan yung index? Okay, 127 guys. 127 yung possible na models na magagawa. Ang dami niyan, no? 127. So these are all the possible models. Kung pito yung ano natin, pito yung regressors, you can generate, you can generate 127 possible regression models. Okay? Lahat yan guys, 127. Nagkasya ba? Okay, nagkasya. 127 all in all. Okay? So isa-isa yan guys. Explain ko lang yung iba. No? Number 1. Ano yung end guys? Isa lang predictor. Okay, pag isa lang predictor, education ang gagamitin natin. Pag education pa lang gagamitin natin, ito yung R squared niya. Ito yung adjusted R squared. Ito yung Mallows CP. Note guys na ito, lahat ng 1 lang ang gagamitin. Diba? Ito. Ito lahat 1. Take a look at this guys. It tells us kung 1 lang gagamitin na to, kung 1 yung gagamitin, isa lang variable, okay, ang pipiliin nyo si education. Number 1 yun. Ang pangalawa, si experience. Ang pangatlo, si tenure. Anong basis niya? Binase siguro sa adjusted R squared. Hindi. Not the adjusted R squared. 1, 3, 5, 6, 7. Okay. Sorry, ano ba ibig sabihin ito? Okay. Anyway, forget this muna. No? Importante dito, pag isa lang yung variable natin na predictor, ito yung mga results. Pag dalawa naman guys, lahat ng dalawa, so marami yan kasi combination yan, di ba? Ito, ano yan, permutation na. So, medyo, okay, ito na yan. No? Highlight. Anyway, yung lahat ng dalawa, ano yan guys, naka-itemize. No? So, very comprehensive guys yung ano. Very comprehensive itong OLSRR. Okay, 2. Yan, 2. Education with tenure, education and gender, education and experience. So lahat siya guys, no? Lahat ng possible combinations ilalagay niya. Ganun din yung 3, ganun din yung 4, ganun din yung 5. Okay? So sa 4 guys, andito yung best model natin based on ano, di ba? Based on p-value, di ba? Education, tenure, gender, ito ba? And civil status. And it has the lowest Mallows, no? Ito yung adjusted R squared na, 36. Okay, makikita natin dito guys, ito yung best combination. Alright, so lahat yan guys, naka-plot dito yan naka-plot dito yan sa OLS step all possible. Grabe guys yung OLS RR. it will really save you. Imagine doing that, yung 127 models yan, one at a time. Okay, so it's almost 9:15 guys. Tapusin mo na lang to. Okay. And then, ito guys, no, nakalagay. Okay, as a data frame siya. Okay, 127 dito. So, binagyan niya guys, kung ang predictor ito, R squared, adjusted R squared CP. As a data frame lang. Tapos ito yung mga predictors. Yung kanina guys, okay, as a data frame lang natin nilagay dito. Okay, it's the same. Alright, then, i-plot natin, anong gagawin itong plot? It will give us an interesting plot. Ito siya. Okay. Ano itong plot na to? Okay. So what is this plot, guys? Okay. So ito, guys, in terms of R squared, in terms of CP, in terms of adjusted R squared, in terms of ASC, what does this tell us? Kung dalawa lang yung variables na gagamitin natin, model 8 is the best. Kung tatlong variables, model 29. If it's 4 variables, 64. If it's 5 variables, model 99. If it's 6 variables, 120. Tapos ito 120 yung natin. So it will tell us here ano yung best na model if you're using 4 variables. Yung 64 na to guys, ito yung kanina, ano? Yung apat na final model natin. Yun. Okay, also in terms of this other two, hindi lang siya na-show na. Okay, so let me pause recording now. Stop recording na ako.